Hello. Good morning all. I, Kuldeep Raj, CGM Production DGH, welcome all delegates and participants from all over ENP sector on this technical session, Production Optimization and Enhancement Technologies. The session will be moderated by Shri S.K. Mehrotra sir. He is having vast experience in ENP industry for more than 35 years and retired as Director Onshore from ONGC. Each speaker will be having time for 8 minutes for his presentation. Now I invite Shri S.K. Mehrotra sir to take over the session. I wish a fruitful session for all. Thank you, sir. Please. Yes, please.
Good morning to all of you. I will request everybody to take the seats so that we are already delayed by 10 minutes. As already introduced to you about the technical session 1, this session is about production optimization and enhancement technologies. I think many of you might be aware of there are 2 parts in that. One, we are talking about the production optimizations, and second is how do we enhance the production through various technologies. What is we mean by this optimization and increase in technology, because it is very crucial to maximize the production efficiency, reducing costs and optimizing the asset performance. That's the theme of this session. And most of the speakers who will be coming, I will expect them to speak on that subject a little bit. Production optimization, I will request all of you to start from sand, well, area, field, reservoir, and then go to the cluster of fields. And we should start optimization from perforations till the sales point. That is what we are looking for, both subsurface and surface. We have 4 speakers, not taking much time. We will start with the first speaker. The first speaker is Mr. Vinod. He is the Director, India Middle East from Gaffney Klein Associates, based in Dubai. And Vinod has 20 years of experience in upstream oil and gas. He has a specific experience about CCUS, hydrogen production enhancement, oil and gas supply chain, strategy and merger and acquisitions. I will request Vinod to start. As you are aware of that, we have 8 minutes for you to deliver. I will request the audience that question answers will be after the conclusion of all the 4 speakers. We have 4 speakers. Welcome, Mr. Vinod.
Thank you, Mr. Mehrotra ji. Good morning, everyone. Thanks for making for this presentation. My name is Vinod Raghutam Rao. As the speaker panelists introduced me, I'm Director Middle East in India, and I'm based out of Dubai. I work for Gaffney Klein Associates. The presentation or the paper, what we have submitted, is a joint effort by my colleague, Mr. Chris Freeman, who's based in the UK. Unfortunately, he could not make it today, but I'm there to present on his behalf with my contribution as well. Yeah. First and foremost, of course, when we talk about production optimization, okay, what comes to our mind definitely is, okay, why do we do this, optimize the production? First and foremost is definitely the aging of the asset, which is the mature field. So as we know, probably 60% of the world's production is probably from mature fields, probably by mature fields which are like greater than 22 decades old. And of course, the average recovery factor is probably being 70% oil and gas, 35% oil innovative methodologies. I think the key or the crux of this is to how do we extract more oil? How do we optimize production from these aging, mature fields, I think. Because these days, if you see, a lot of companies, operators are kind of going behind, in terms of new discoveries and so on. Of course, that's good, but there's always a trade-off because, when you're spending more of CapEx trying to get in more exploration, but you realize it's a dry well, it's rather kind of more kind of smart way of optimizing your and enhancing your production from your existing age field, because you know the field, but you also know what it can produce and how you can take it to the last mile and so on. And what you see on the right is mostly of what we classify as primary recovery with the natural for artificial ALTs, the secondary recovery, and last but not least is the tertiary recovery, which, as you know, is split between thermal, gas injection, chemical, polymers, and others, and so on. So I think these are some of these production optimization methodologies and technologies which I'm sure not just in India, but even the global operators, oil and gas E&P companies use. Of course, the foremost is definitely, as you say, the law of diminishing return. More and more effort is required and cost to produce than to recover less and less oil. That is true. But the trade-off being even probably a 1% increase in recovery can probably generate significant returns. I mean, probably which is equal to discovery of a medium-sized field, which is probably just cost 5 to 10% of exploration of a new field. So, and particularly in India, of course, Mumbai Hive, which we have worked for several decades as part of Gaffney Clan, is one of the largest mature oil field in India. Moving on, so this is what our Gaffney perspective of mature field optimization. Okay, the process starts with reservoir management, facilities, and commercial. And of course, as in any process, the way we encounter what are the current challenges in that field, and how do we use catalysts, and then how do we scale it up, and so on. Of course, the challenge being trying to get the integrated analysis, bringing perspective on different operations, and for potential game changes, which probably I'll discuss in the next few slides. So these are some of the challenges you need to identify as part of mature field optimization, starting with, as you mentioned, reservoir management, allocation, gas water breakthrough, wells completion, lift technologies, and also not to forget the commercials, because one thing is getting all the technical in place, but if there's a huge impact on economics, cost economics, and so on, that could kind of tilt the balance in a different directions. So having kind of have a well-integrated, like a 360 validation of all these reserve management facilities and commercial would only kind of give you a kind of a go or no-go decision on how do you kind of optimize your mature fields and so on. And again, when you come to catalysts, you would say probably how do you identify the candidate solutions, candidate fields of what we could do, and also work with your technical providers in understanding how we implement mature field optimization and so on. So that having a thorough plan would help you kind of embark on a well-crafted strategy to kind of enhance your production. Having said so, let's probably look at some of the challenges of mature field optimization. Of course, the first and foremost, as we see at Gaffney, is always data. Data is probably the new oil. As we see, that data is always critical, even though it could be old data, but it's good to kind of review, kind of do a thoroughbred review, validation of the data, so that we know what is kind of lacking, what can be done to fix that to probably bring to the next level and so on. And also, of course, not to kind of discount it, you need to understand your laws, regulation, contracts, and your physical setup, your facilities, and so on. So these are kind of challenges one faces in terms of how you go about optimizing mature fields and so on. And as I mentioned in the previous slides, on the right, what you see are some of these new technologies or game changers with the 3D visualization, 4D seismic, horizontal drilling, fracture stimulation, real-time pore pressure, facility revamp, and so on and so forth. Of course, there's no one-size-fits-all, and definitely there could be a mix and match of these different technologies, methodologies one should use. Again, the combination of your economics to make sure that you have a well-defined implementation plan for your mature field optimization. Of course, the crux is, again, having the right people and also the talent, which I'll again discuss, because one thing is to have the strategy, but the next thing, or the most important thing, is how you implement, execute it, and get your desired results and so on. Again, speaking about mature field reserve management, of course, definitely the reserve management, as you all know, of mature fields is challenging and hard work, and more and more will require to produce less on oil, similar to what I mentioned in the first slide about law of diminishing returns. The key takeaway from this slide probably would be, of course, data acquisition is key, and then you do understand a detailed reservoir management plan and should be prepared well in advance. And again, I can't emphasize more, even the old data, what you obtained in the previous one, is very critical and crucial. And that many we have noticed sometimes that it could kind of change your strategy and it could probably mislead you in a different direction and so on. I'll probably just click this slide. Continuous improvement is key. I mean, the reason what you see on the left side is what are the different examples you could do probably to optimize your mature field optimization in terms of reopening shut-in wells, collect more data, improve reservoir sweep, and so on. But the first and foremost, are we prioritizing and focusing on the right things? Are we flagging the right issues to be solved in terms of short equipment, vessels, and procurement, and so on? So these are kind of some of the things as a checklist you need to kind of really go back and check whether all these are in place to see whether how we go about a continuous improvement of your mature field optimization. And on the right side, of course, there are some innovative and out-of-box thinking is required, especially, companies do a traditional way of managing their assets, so are trying to understand how do we do things differently? How do we reduce the decline, production decline? Can we collect more data efficiently? Do we need all this equipment? So these are some of the questions probably one has to kind of introspect to understand where are we in this journey? How do we go about trying different techniques and methods and so on? And again, going back, what is the reservoir telling us? Oh, it all comes from our data. What do we do? And end of the day, do we have the right leadership to go ahead and execute this and so on? And whether you're motivated and dedicated and so on. So these are some of the mix and match of, I would say, production optimization methodologies and technologies, and the ways one can probably utilize them to go ahead and see how we could go about it. On the next few slides, you can see some few examples which Pavel will go through. They're all in the public domain. The first and foremost is the Montrose field history, which was discovered at Amoco in 1971. And if you see on the right side, what has really worked for them is probably, I think a new operator came in, probably in, I think Talisman, if I'm right, in 2012, and also back in 2003 and 2024, there were operator change. So they brought in a lot of kind of funds, capex. They kind of invested in those projects. That's one thing. Similarly, there were a lot of changes in government tax incentives and so on. So these are a combination of these kind of help them bring up the production, optimize the production in their mature field assets. Even though there are 5 operators changing hands, but I think it worked for them. I think they have an enhanced, a good strategy until 2030, if I'm right, for Montrose. It's around in the North Sea, Aberdeen. Again, another example would be the Beatrice field, again in the UK North Sea. Same, if you see, the new operator came in sometime in 2002 and also probably later, wherein they brought in new synergies, having a wind farm also. They got a new operator ideas like satellite tie-in, intervention, and so on. So a combination of new operator, changes in technologies, and so on. So this kind of set up a new kind of a roadmap for Beatrice, and they were able to enhance, optimize the production from their mature field assets. The last example I have is the Fortis field, again, you cannot see. Again, similar, I mean, they kind of also brought in a new operator. I think one common pattern I saw in all these 3 examples, having a new operator with different ideas, fresh sets of thoughts, and so on, new ways of working, and they do get what, probably in this case, they did 4D seismic and infill wheels drilling and so on and so forth. So the last slide to conclude is definitely the global production is for mature fields. The mature fields require a different philosophy on how you handle it and so on. We do understand, having worked in different parts of the world like UK, Kazakhstan, Kuwait, and so on, it is hard work and labor intensive, but definitely even a significant marginal 1% recovery is significant in terms of cost-wise and so on. And definitely data, and cannot re-emphasize more, the people, the staff is very important, because once this, what you know, but how do you implement it, go about it is critical and crucial. And it's not just you do it once for all, but it's a continuous improvement process so that you kind of revisit the data, go about the continuous improvement of how do you optimize. It could be a cyclical process, but need to be everlasting and so on. And the future can definitely be bright if you have the best and bright resources on how to improve production, recovery, extended life of the field, and of course, to do it, I can't emphasize more, we need smart people and strong leadership, and last but not least, investment. Thank you.
I think we will have question and answers at the end of the session. Our second speaker is Mr. Sunil Rastogi. He will be presenting on optimizing and augmenting production through the initiatives, innovation, and development. Sunil has 40 years of experience. Sunil, I personally know him. He has worked in ONGC for many years. Then he went to Reliance Industries. Sunil had a good experience of putting MA field in KG Basin. Currently, Sunil is involved with Sun Petroleum, and he had been instrumental in increasing as well as optimizing the production both. And again, we know the small thing to you. Optimization means the production level that is continuing today. We must maintain it. Enhancement means we get that delta available, which you have shown by that thing. Welcome, Sunil, and we would like to tell you that please restrict in 8 minutes.
Good morning, all. So my story of Sun Petro is just extension of what previous speaker said, we bring new operator. So we got some fields, and so my mantra of my company is speed with accuracy and scale, and my leadership is having a strong commitment to succeed by Make in India and Atmanirbhar Bharat by indigenous innovations. Company is diversified in oil and gas in 2014, and it is promoted by directors of Sun Pharma. Company has taken non-performing fields, Baula, Modera, and Hazira, and later on from Reliance, this Bhaskar field. So this presentation is just turnaround of these fields through technology, innovations, initiatives, and developments. Baula and Modera we took on 10th June 2016 from Interlink Petroleum Limited. They got this field in 1995. They produced some gas from 2001 to 2004. And another field, Hazira, we took from GSPC NICO. It was on the verge of abandonment on 30th September 2017. And we started operating from 1st October 2017, and we are still operating it. And Bhaskar is we took from Reliance BP. The story will come further. So what we did different, and that difference brought, we use less capex and less opex, and we implemented actually dozen of patents. We did in-house innovations which we implemented. It will come in the course, and so far we have 12 patents, and we have filing something another 48 patents, and now we are going for discovered small fields which are in offshore blocks, and there also we have in-house innovations in terms of platforms, in terms of our own bars. It will come subsequently. So not to go on this, Baula Modera is having oil of API gravity 12.8 to 13.2, very heavy oil. It is the worst oil in India which is being produced. We use Ukrainian technology and some in-house innovations in the sense of we use deep penetration charges. We use in-house designed backwashing system for unconsolidated reservoirs, and we have this storage tanks what we are using. We have more heatings, and these fields are continuously producing from January 2017 till last year. We produced 103 barrels per day from these, and they were having earlier zero productions. Going forward, the Hazira field, after taking over, it was uneconomical for the earlier operators. So from day one, we started, you can say optimization or reduction. We reduce power consumption, we reduce fuel gas consumption, we reduce water consumption, we reduce chemical consumption, we optimize vehicles, we optimize vessel trips, and we do number of work hours. We tried almost on 20 wells, and drastic reduction in manpower was one of the, So bringing new operator definitely do helps, because he sees the things differently. And since earlier operator was to abandon this field, he was not maintaining it from last 5 years. So after taking over, I have to do extensive maintenance and lot of certification, lot of inspection by OSD, DGMS, and we could achieve all. And I have the almost all OSD compliance, DGMS, we have done it. Now comes to how we increase the production. We did in offshore well, we did the rigless workover job through slick line, And we were successful, and we completed the job within 3 days. That well is still producing another 20,000 cubic meter of gas. We did in-house design, chemical stimulation jobs in 2 wells, and we could increase production from 70 barrels to even touch 500 barrels. And still we are producing more than 100 barrels. Now coming to Bhaskar field, which we got from Reliance. This field, as per field development plan, it was to produce 3,100 barrels per day maximum. And by our in-house initiatives, many, you can think about, we use surge controller, we use cyclone in the separators, we are having zero gas flaring by liquid UCL, lot many. And in starting, we were transferring this oil to ONGC Akhajuni. They were having problems in receiving this much quantity of oil, what we intend to produce. So in spite of laying a 6-inch line to ONGC, we have to lay another line 10-inch from our field to IOC Bareja, 10 kilometer, 60 kilometer pipeline, 10-inch, we laid in record time of 8 months. So whatever we do with speed and accuracy and scale. So what was the success regions? We did, whenever we did 17 wells, new wells in this, all unsuccessful. We did multiple level of validations, in-house, outside, subject matter expert, to ensure that we get the oil. We constructed the CPF central processing facility in this field in the record time of 2 years within the COVID period, which was possible because of leadership commitment. And we implemented zero gas flaring. We are selling all the gas from this field to the nearby consumers. We have the interpretation center in the Mumbai for, our study purpose. These are the field innovations, cyclone, zero gas flaring. We have the mobile separator for testing purpose. We have the ejector for recovering low pressure gas, Pigable Y. Then the new development are coming. We have the 2 discovered small field in Gulf of Kutch, GK28, and Gulf of Khambaj, Gulf A, which we are going to develop Gulf A through this hybrid platform. This we are constructing, it is in-house design. And then we have designed this circular bars, which will take the rig to the hybrid platform, and we will drill the well in offshore through the onshore rig. This, we are constructing our own platforms. It is low-weight platform of 1,400 tons. It is much lesser than the used traditionally, and to reduce the cost. This is going to be used in the GK28. Then we are thinking of in the power also, to have the power self-sufficient by the renewable power on the offshore. So this is our journey from zero production to 8,000 barrels. And we are producing 8,000 barrels. We intend to go with the current things only 12,000 barrels. Next year, I intend to add another 10,000 barrels from Gulf A. And we have the 4 big exploratory blocks, and any big discovery can be game changers. So, and we are having record of 0 LTI till date, and we want to continue. We are very environmental friendly company. We have lot of plantation. I can vouch on that. We have the maximum green net of our area. And with this approach, with in-house innovations, and we wish to be, in first 3 of the India in oil production. Thank you. Thank you, sir.
Our time is, we are running on time? Okay. I think very fast presentation by Sunil, and covering a lot of areas. We have some questions which we will later on talk for benefit of all attendees. Our third speaker is Adarsh Kumar. He is a DGM with SR Oil and Gas. His title for today's production announcement session is Reduced Rod Wear and Runtime Increment with Modified Completion in Progressive Cavity Pump, PC pump in CBM. Others have about 3 years of experience in CBM in running edge CBM block of West Bengal, operated by SR. They have about 340 wells and 300 kilometer in field pipeline. We all are aware of SR reached a very good peak production from this field. And now he will be talking about his experience. I welcome others to give his presentation. Others.
Good morning all. So we are, as a SR, we are the largest producer of the CBM in India. And today I am going to discuss more about the reduced rod tubing wear and runtime increment with modified completions in PCP wells. So the agenda for the today discussion is how the PCP completions in CBM wells, what are the failure types in PCP completions, what are the root cause failure analysis we adopted, and some conclusion we have drawn from our failure analysis. So this is the introduction of PCP completions in CBM wells. As we all know, we have to dewater first to produce gas. So we use PCP as an artificial lift. The advantage of using PCP is because of its it can handle high solid content, and it also can be run effectively in vertical or directional wells up to some depth like 1200 meter to 1300 meter. We use rod PCP. We do not use rodless PCP till yet, and it also has favorable economics as compared to other artificial lifts. So our general completion sequences is tubing we are using of 2.7 by 8 inch. We are using stator of different manufacture. We are using sucker rod and drive rod of different body and sizes. We use some hybrid anchor below the pump, and we use no-turn tool to provide its restrictions. So in CBM we have to continuous run the well, because in our case if the wells get stopped, the gas saturations again resaturate and we take another some amount of time to recover that gas. So this is the failure type in PCB completion which we face in SR. The major failure which we face is because of the hole in tubing. So this is the trend of 18 months which we face, and the 50% contribution is because of hole in tubing. And hole in tubing in the which we can extend to some time. And we in SR we have the deviated wells, mostly L type, and some of the wells are S type. So we are trying to optimize how to use that completions and how to increase our mean time between failure. So in this presentation, we mainly focus on how to control hole in tubing. Some of the major failure also happens is like rotor parted, stator failure, burning of a stator, breakage of rod, etc. So the next is hole in tubing causes. What are the main causes of the hole in tubing? So first is the cause of contact loading. As we know that there are many wells like L-type wells and S-type wells. So the contact loading is high at that point, and in vertical wells there is a minimal contact loading due to not having that deviated curvature. And second is the hole in tubing cause is due to the eccentric motion of the rotor. As we know that progressive cavity pumps translates and rotates both, so it creates long eccentric motion which causes the high oscillations, and it results to a wear, tubing and rod wear. So we have adopted 3 solutions for hole in tubing. First is for solution for L-type well profiles, where in past we are using 2.7 by 8 inch tubing with full size couplings. It is of OD 46 mm full size coupling, and tubing ID is almost about 72 mm. So we have replaced with 3.5 inch tubing, and with slim hole couplings we have increased the ID, and we have seen the major changes that's seen in the PPT also, that the runtime has been increased from 200 days to 400 days. It's almost the double. This is the simulation done in the CIFER software. Second is that we are having some S-type profile wells. So S-type profile wells creates problem for us, because when running in the completions, it causes the torque fluctuations which leads to multiple failures like hole in tubing, rod breakage, elastomer failure, so that we can't able to run our wells smoothly. So we know that there is some solutions like using of continuous rod for that, but it is quite costly. As we know that CBM is a low margin business, so we have done some changes here, is that we have mixed the completion with pony rod, short rods and with long rods, and we have changes the tubing size so that we can create the more spaces. So this is the result which we have done, and this is the simulation. Here we can see that at that upper section there is a contact loading of 55 Newton, but we have reduced that contact loading to 10 Newton. And in previous example you can see also our wells that how the torque fluctuation is done in the previous, but after that the torque fluctuation has been reduced and well is also running very smoothly. And third is the case where its major case is that because we have the problem of hole in tubing just above the pump. So it is because of the inherent nature of progressive cavity pump. This thing we can extend by using some optimal solution. So we have changed to 7 by 8 inch tubing with 3.5 inch tubing to create more eccentric motion, and we have find some good results, and we have optimized it in 150 wells, and where we see the incremental mean time between failure also. So the conclusion for this is that industry has adopted many solutions for PCP that like boronized tubing, laser seal coupling, line pipe tubing, but as we know that these solutions come with a cost. So we have to optimize the cost also, and we have to play with our economics and run time also. So we have get three results from this. First result is use of 3.5 inch tubing with slim hole coupling in the entire completion string to reduce the contact load where DLS is very high. Second is use of pony rod completion where there is crooked well to simulate the similar behavior of continuous rod. As we have done many case study with simulating the similar behavior of continuous sucker rod with the help of shorter and longer rods which we have, and we are quite getting good results in that. And third is use of 3.5 inch tubing that we already discussed how it helps us. So these are some of the reference which I take for making this paper, and that's all.
Our fourth and last speaker is Aman Saraf. Aman is field engineer from Schlumberger India Coil Tubing Services Division. He will be speaking on deliquefying and reviving gas wells with a velocity string, coil tubing deployed future ready completions. Aman has got experience of over 9 years in coil tubing operations both in onshore and offshore, and successfully has done job of velocity string installations, tubing curved perforations, water set-offs and control in HPST wells also. He has 3 SP paper publications on HPST operations to his credit. Welcome, Aman. Speak about it. Probably he's going to speak on Kane's field, Rageshwari gas field. Yes, he will be giving his experience on Rageshwari gas fields of Kane.
Okay, good morning everyone. I'm Aman Saraf. I'm from Schlumberger Coil Tubing. So today I'll be presenting our Schlumberger's work with Vedanta for the past 2 years on velocity string. So Rageshwari gas field in western Rajasthan, basically it's a prominent gas field over there. However, the reservoir pressures, they have been declining continuously, and because of the decline in the reservoir pressures, water loading happens very often in these wells. These wells have turned cyclic. So basically the wells that were running on, let's say, 90 to 100% run time, now they are running at 20 to 30% run time because of the water loading. So unless the gas pressure builds enough, they don't start. So there are a few ways to conquer this, to remove this. One of them is velocity string. So our operator has tried 3 or 4 ways, but velocity string has proven much more effective. And I'm going to just speak about it from an operator's perspective, that how did we install the velocity string and what were the challenges for us. So the type of velocity string that we were installing for Rajasthan field is a packer type velocity string. So the advantages of using a packer type velocity string is that we don't have to change anything on the surface. The wellet remains same. And the velocity string was additionally fitted with upper completion, so we have a profile that can allow flow from you will have the flow from the velocity string, you will have flow from the annulus as well, and you can have concurrent flows as well. Starting with the velocity string design, the first thing that we look at is selecting the optimum tubing. Basically, the optimum tubing depends on 2-3 characters. The operator has to decide that how well a velocity string will reduce its Pmin and Qmin, so that the flow can be reduced, limiting flow can be reduced, and even the Pmin can be reduced, so the ultimate recovery is optimized. Once that is done, once the OD of the coil has been finalized, then we come into play and we have to understand that what is the thickness of the coil tubing that we should take, so that we have we don't overexpend on it, but we get the right thing and we do the job safely. So I've just represented some cases. Basically, these are the pre-check cases that we consider while we are installing the velocity string, and we know that everything is within the limits so that we can install it safely. This is the basic BHA diagram for a velocity string. It comes with a lower portion of the DPOP BHA. So these velocity strings are being run in live wells. So we need an isolation sort of a BHA in the bottom. So that is the DPOP BHA. Then you have the coil tubing string. So that is being run as a velocity string. Above that you have another connector. So basically you can connect the upper completion part. Then comes the upper completion part, which will facilitate you so that you can have flow from the annulus, flow from the velocity string, and concurrent flows as well. And last is the running BHA that we run. So that is deployed by the coil tubing team. These are the various stages of the process. So once we have run in with the DPOP BHA, we cut the coil tubing at surface, make up the other connector, and do the pressure test and pull test of those connectors, make a running BHA, and once the running BHA is made, we make it connected to the upper completion BHA, and then the final stack is made up. We run in whole, and finally we set the velocity string. This is a basically ball drop sort of a mechanism. So just a ball is dropped with pressure up to, it's same as a bridge plug, you set a bridge plug. So similar kind of mechanism is used. Then the last process is that once you have installed the velocity string, you want to now connect it to the reservoir. Earlier you have run it with a DPOP BHA so that it acts as a barrier. Now you want to break that barrier. So we do it with a nitrogen, pressurizing the string with nitrogen, and what you see is a packer working envelope. So basically, depending on the strength of the packer, you will have to see that what can be the activation pressure. So I've just plotted a simple plot, assuming assuming in case the liquid columns are known, then you have the 2D plot in front of you. You can refer to that. Assuming that you don't have the liquid column known, then basically we'll have a plot that comes with two relations. So liquid column and the activation pressure that you want to set combined with the packer envelope. So this is the range that you can go. So what are the challenges that a coil tubing operator would face while installing these kind of velocity string? The first challenge is a very high stack. So in our operations over there, the stack was almost 99 feet high. That was the highest stack that we had installed with a 2-inch coil tubing. So basically a 2-inch velocity string. So basically, how do we know that this kind of a stack is safe to make? How do we secure that stack? So we used some technology aids that are available in the market. So one of them being the zeta analysis provided by NOV. So that allowed us to understand the yield stresses in the stack while we are operating at the maximum ranges. So basically the 99 feet stack, we confirmed that this is below the 50% yield stress rating. After that, we also wanted to be sure that wind, basically once we are rigged up in such a high stack, it can be, wind can start, and basically you can have a turnaround in the surroundings, and so we needed a limit on that as well. So with the same simulation process, we were able to get it, and we were able to limit it at 15 knots per hour, so making our operations a little safer, so we could predict basically if the environment is fine, and then go ahead. The last thing was the securing of the stack. So securing of the stack, we had additional securing. Instead of the normal 4-point securing, we went with the 8-point securing. So this is an actual photo of the scaffolding that we were using to deploy the upper completion BHA. The second challenge is the long BHA deployment, because the upper completion string comes with the premium threads. You cannot really make it on the field. So what you have to do is you have to make the complete string and then bring it on the field. How to deploy it? So we pre-made the risers, we pre-made the scaffoldings, so that it could be kept aside and we can just latch it onto that. The last challenge is the live well deployment. So there are various stages of deploying the velocity string. We had to make sure that we had the primary secondary barriers in place, and over that we had well controlled contingencies over there. So we had the kill fluids ready, and we had the provisions. Even while we were cutting, we had the provisions of pumping. So whenever the coil was cut, so even then we could basically make a connector in the T and line up our lines. So if there is any mishappenings over there, we can just control it immediately. So the results and benefits, basically as you see, the production enhancement is a major benefit that you will receive with the velocity string. So it increases the production rate, it also increases the ultimate recovery, and basically what you see on the right side of the table, we have installed 7 velocity strings in the last 1.5 years. All of them have resulted in 100% uptime of the wells. The initial uptime of the wells was around 10 to 50%, and these numbers are after flowing of the wells for at least 3 months. And with installation from coil tubing, the advantage is the coil tubing operations are much faster. We are in hole for less than 24 hours and we are doing the job within that time span, so that really does not hamper the production of the well while we are doing these jobs. And now our client has opted for the field level deployment of this technology. I am very grateful for Vedanta team for giving us this opportunity for performing these jobs. That's it from my side. Thank you.
We have some time? Okay, let me conclude it. Then we will have some question and answers, which I have. First thing, we know what you talked about. I have again said that as per your presentation, you talk the water injection secondary recovery up to 30%. We feel that it should start from the beginning of the field. This was the first comment. You can speak after 2 minutes when I. Second is that about optimization. I said what we should do it for enhancement. There should be separate campaign for that. Sunil, it was very excellent presentation of yours. It says that capex and opex, this is can make things good or bad, and there is a huge amount of thinking process. If we can reduce both the capex and opex, we can put many of the fields which are today abandoned or which are not being produced. That belief has been taken out by the presentation of Sunil. Sunil, you talked about technology, which can again do it. Technology doesn't mean it's a very hi-fi technology, even if in-house has mattered a lot, which I am aware of the fact. Third is that the change which you talked about, the new operator, new thinking, new ways of thinking, that also brings the change. That is why government has come out with one policy known as a DSF, to offer it to others to see that if we can do it, even if government oil companies are doing that. Third, again, your presentation was excellent. What I suggested to you is that to see that how do we make the PCP made, custom made for us. That is what the innovation we are talking about. How the tubings can be made with the same budget. What are the changes in the tubing can be made? What are the changes pony rod? You have so many examples of hundreds of pieces already have come out. Do research on that. You will get the success. We have seen that. Third is C-tube based. Again, since the gatherings are here, the advantage of C-tube based is that you can do pressure. You can do the job without killing the well. And I think there is exhaustive use of C2 required in India, at least in on-land operations. We use so many workover rigs. I don't feel that we can do it. The C2 is the thing which I feel. And Aman, it was very good. I think you are able to take care about safety also. It's possible to do it. This is what is there. If there are any questions, we can take 2-3 questions from audience. Anybody? Yes.
Hello. My question is Adarsh Kumar in PCP. So my simple question is, are you using the both tool, hybrid anchor and no tools, in same completions?
No, sir. Where we are using hybrid anchor is because of having the coal ingress and where we are having the gas ingress. We are not using the same completion everywhere in the hybrid anchor and no turn tool. Our general completion is the pump and after that no turn tool. We use hybrid anchor in the case where we are seeing the excess coal fines or we are seeing the gas is entering through the pump.
Okay. Because my question is, we are facing the unscrew the tubing in generally in PCP pumps, so in deviation wells generally. So that's why I ask you, because we are using the both tools, then the reduce the unscrew the pump in deviation wells.
My one suggestion to you, there is a torque chart for the spinner of tightening the tubing. For 2.7/8 tubing, the torque is almost around the range 2000 to 2500 feet-pound. If you are giving the extra torque with the spinner while running in the well, it may get tightened and it may get the chance of having unscrewed.
Okay, thank you.
Respected ladies and gentlemen, a very good morning to one and all. On behalf of the organizing committee, as a technical committee team member, I extend my heartfelt gratitude to esteemed session chair, Sri S.K. Moitta sir, and speakers for your active participation in the session. Your presence have truly enlightened us and engaged us in the event and made it an enlightened one. We are privileged to have a distinguished speakers who shared invaluable insights to how production enhancement technologies can boost oil and gas production. By mature field optimization to implementation of the new technologies, to revive the fields which were in the verge of abandonment, and in-house innovations as well. By leveraging technology and domain experts, we can achieve a win-win outcome. But my friends, let us not stop here. Let us carry forward the knowledge gained here to enhance our industry resilience and sustainability. Once again, I thank you for your active participation and will look forward to future collaborations as well. Thank you. Now, I would like to request our session coordinator, Sri Kuldeep Raj sir, to please come on the stage to present a token of appreciation. First and foremost, I would like to invite our session's chair, Sri S.K. Moitta sir, ex-director ONGC, to present a token of appreciation, please. Moving forward, I would like to invite Mr. Vinod, Director, India Middle East, GC. Mr. Sunil Rastogi, VP Head Operations and Petrochemicals Private Limited. Mr. Adarsh Kumar, Deputy Manager Production of SR Oil and Gas Exploration Private Limited. Mr. Aman Sharaf, Field Engineer of Schlumberger. I once again thank everyone for your active participation. Can we have a big round of applause for the team members and the speakers, please? We'll also have a group photo with the team members and the speakers. I would like to invite all the speakers to the stage, please. Thank you very much.
बैग देना पड़ेगा.
Good afternoon to all members present here. This session is for advancement in drilling technology. May I request Shri Anurag Sharma, sir, former director onshore ONGC, to chair the session on advancement in drilling technology. Sir, please. Anurag Sharma sir worked in the various important positions in ONGC and ONGC Videsh Limited in asset management, operations and services. He is a master in drilling. So in this session we have 3 presenters, as fourth one is not unable to come. So first session will start from Mr. Satish Srinivasan on screen pulse enhanced recovery system. Mr. Satish Srinivasan is from Schlumberger. He has wide experience in various field operation and more than 11 years in Schlumberger. Presently, he is associated in well construction equipment sales department of MIA Swaco product line of Schlumberger. So I request Mr. Srinivasan, please come and start the presentation.
Yeah, thank you everyone for this wonderful opportunity to present our technology. Today I will be presenting the screen pulse, which is screen pulse cutting separator. The screen pulse is just an attachment which is normally attached to a shale shaker. The shale shaker being a primary solid control equipment that used to be there in almost of the rigs. So what is special in this screen pulse? This screen pulse, it is attached to the last panel of the shale shaker. So this is a normal vacuum system, so which transmits a pulse of vacuum to remove the excess waste or excess mud that is being discarded. So this gives us an enhancement to recover the excess fluid and reduce the disposal cost of the waste. Because if the cuttings are wet, so there will be more waste that will be generated, and resulting in the further disposal of this waste and tucking cost. So it is a small vacuum pan that is being installed on the last panel of the shale shaker underneath the screens. So this is the resemblance of the actual one, how it looks. This is the vacuum pan. The black one is the vacuum pan, and the hose that is connected from a pneumatic panel, and that is controlled by a timer with an on-off signal of 2 minutes, and which we can even vary the timing. So this is a short video how the screen pulse works. When the pulse is on, the cuttings are dry, and when the pulse is off, the cuttings will be wet. So I'm just starting this video. Here we can see that the cuttings are wet, and after some time it gets little bit wet. Moving on to the next one. Yeah, this screen pulse, this can recover at 25 barrels per day of drilling fluid, and this adds up to a further reduction of waste by 25%. And the oil on cuttings on an average is near to 10% by weight, and this even helps mixing of the additional waste with the drilling fluids, and it maintains the drilling fluid properties. So this is the normal paint filter testing, how the liquid part is being extracted when the pulse is on, when the pulse is given at the ambient temperature. And the bottom one is the picture on day one, where we can see too much of oil that is being released from these cuttings without the screen pulse. And the next one is with screen pulse, how the cuttings looks. It's very dry. And this is the example where this was installed in a VSM 300 shaker, and nearly $2,500 per barrel of fluids has been recovered, and which amounting to a total of 220 barrels, and resulting in a 520K of money that has been saved. And the last one is this screen pulse is MI-SWACO proprietary technology, but it can be even fitted in any of the shakers, some of the other shakers like Brand, VSM 300, King, Cobra, Derrick, FLC 500 and Hyperpool. Yeah, thank you.
Thanks, Satish. Wait for a minute. There might be some questions. So for excellent presentation and the product which you just demonstrated, we get drier cuttings and we enhance the recovery of mud is also more. So in a sense, we are reducing waste treatment, transportation and disposal fees, and the cost reduction also, which also you demonstrated. So any questions to him?
Yeah, thank you. I think it's a good technology you are demonstrating to us. So I just wanted to say that is it a replacement of cutting dryer, or second thing is, I mean, you say that you are able to recover the 10%. So 10% is non-recoverable, which I understand, because with the cutting dryer we can go up to 2%.
Yeah, thank you very much for the question. The cutting dryer, it can recover surplus amount of cutting oil from the cuttings, but the G-force that the cutting dryer has is near to 328 G-force. Such a high G-force, it really smashes the cuttings and breaks into pieces, and the final recovered mud that we supply, it's of different property from the actual one. And in this screen pulse, the pulse is set in such a way that it do not extend the openings of the screen mesh. So it protects the shaker screens, and only the paint testing that I presented in the second last slide, it only recovers the free fluids that can be extracted from the solids.
Any other question?
The oil, you mean to say the cuttings that block the screen openings?
Yeah.
Yeah, that is the reason that we have made it as the pulse. So we can set the pulse according to the time. So 2 seconds on, 2 seconds off. So along with the G-force, this will not block the openings.
So does it also enhance the longevity of screens as compared to the conventional shield shaker screens?
Longevity, this has been perfectly designed so that the screen mesh do not get damaged. So the maximum PSI pressure we maintain is 20 to 30 PSI for the last panel. So this has been tested and this pressure has been set for the safer operation of the screens.
Okay, any other? Thanks a lot. Thank you very much.
Thank you.
You will invite? Okay.
Second presentation on Tripura asset has put its exploratory well back on track after recovering complete fish by spotting enzyme pills. I invite Mr. Muhammad Imtiaz. He's from ONGC. He has worked with ONGC in various assets. He is expert in well completion and drilling operations and well-designed production, high-pressure gas wells, workover operations, and well intervention services. So I request Mr. Imtiaz.
Thank you, DGH, for giving me this opportunity. I would like to just, there's slight changes. I'm not a drilling engineer, I'm a well completion and testing engineer. And myself, Muhammad Imtiaz from ONGC. Right now I'm going to present about a case study that we used in exploratory well of ONGC Tripura asset, that is a high pressure well. By using a very novel chemical, that is an enzyme that is used for the first time in India, in Tripura, is a northeastern state in India. And here is the presentation overview. And this is just the literature, around literature about stuck pipe event. $400 to $500 million is spent on each year on stuck pipe event. That's a huge amount. And even research found that 70% of the stuck pipe event occur within 2 hours of a shift change. And here is the listed literature. Stuck pipe can be divided into mechanical as well as a differential. And this is the ONGC data. 23% of the pipe stuck occurred due to differential, and hole geometry is 32%, and the pack off is 45%. And stuck pipe is one of the major causes of NPT. And what activities led to the pipe is stuck actually, and what's the major activities? Major activities given in this pie chart is connection and static pipe contributes around 40%, and reaming activity is 33%, and the pulling out is around 20%. Just a literature overview of this. And here is the diagnosis of the stuck pipe of flow chart, which determine which is a differential or the mechanical or a hole bore geometry. It's on the basis of if there is a fluid coming back, or if there is a torque or a drag, is nothing new. And this differential pressures, how the probability changes with the differential pressures. And the probability increases from 20%, more than 20% if the differential pressure is greater than 1000 psi. And this permeable formation adjacent to formation is one of the reason. Second is high differential pressure. Third is thick mud cake and the large contact area around the BHA. And the here is the methodology, why we using enzyme and what should be the reason. First we place a brine bill ahead of the enzyme pill, which act as to dehydrate the filter cake through an osmotic pressure. And then also the brine pill equally act as a spacer. The enzyme work by breaking up the polymers that is used in mud. That is a bad mud cake filter actually. While the weak acid in the pill formation act as a catalyst by accelerating the action of the enzyme, including also dissolving the solids present in the mud. And the aim of the weak acid is to react and dissolve the remaining solid that may be present in the filter cake. The displacement procedure and the recipe need to be properly optimized to get the best result to free the stuck pipe. And after displacing the pill, it should be allowed to soak for 2 to 3 hours. Just normally we do in the HSD or the spotting fluid or oxidizer, we have to soak for some time. Here is the case study for the well number 1 in Tripura. Actually, it's drilled with a 8.5-inch hole, was drilled down around 3200 meter, and it's continued for condition for logging. When the star GR logging tool was lowered by a PCL, the tool was further ran around 3200 305 meters, where held up was encountered, and the string got stuck. And star GL is a very costly tool. It's offered by the SLB, I think. And we work on a string with a circulation maintaining around 800 psi SPP, but stuck could not release. We have also tried around 6 times to release the stuck pipe by HSD or by acid, weak acid, HCl, and this spotting fluid like polylactolite, but no success. And here is also seen that the stuck pipe event occurs in the same region by a blue dot in the middle picture. And it's also the formation is a very shale sandstone and silty stone. What we do is the execution part. Here is the stuck pipe length is around 355 meter. First, we have to do a pre-flush solution of the biosurfactant in the brine. We place a brine in, that is 1%, that's come around 65 liters, and the mean treatment of the 14 meter cube, which consists of the enzyme, acetic acid, biosurfactant, and the brine solutions. Here is the calculation of 1120 liters, 420 liters of acetic acid, and biosurfactant is 175 liters. A string was soaked with a 100 psi surface pressure for 3 hours, and it's released actually, which is a very less time to release the stuck pipe in this event in a very high pressure well. And here is the second well in the same region in the Tripura set, but a different structure. Here is also shows that this comprises of a shale as well as silty stone region that is marked in a point. That's around 896 meters, as shown in this second pictures on the right side. Similarly, we do this execution part of pre-flush solution. In the previous one, we do is a 1% in the solution, but here we do is a 3% biosurfactant. And the enzyme treatment fluid consists of 8% enzyme, acetic acid 3%, and biosurfactant in 1%. That can be optimized as per the scenario. And post-flush is same as the pre-flush. And this time we applied a 800 psi pressure, and the string got released actually. Here is the cost benefit analysis as comparison with the HSD spotting fluid pill as well as the enzyme. For the single job, it comes around 22% is less as compared to conventional stuck pipe. As this is the salient features of the enzyme. Enzymes generally work for the biopolymer based drilling fluid multi filter cakes like the KCl, PHP, MR system. Is fully compatible with the major types of brine in various density up to 100 PCF, and fully functional at a very high temperature up to 135 degrees centigrade. And this enzyme works on a principle of hydrolysis of the mud cake in even break-in action and complete cake removal, and no reaction with the tubing downhole tools or hydrocarbon or formation component, and is environment friendly too. And this conclusion is the stuck pipe can be removed in a very less time, and it's cost very less. And this way forward, this enzyme can be used to decrease the water cut, as we have already used this well in the Bombay offshore, and enzyme can be also used in this well cleanup. Actually, this enzyme can be used to improve the skin factors, so led to the production enhancement. And thank you from my side.
Thank you. Thanks a lot, Imtiaz. Wait a minute. There might be some questions. So you presented 2 case studies, and you demonstrated that the recommended solution of enzyme acid pill worked in both the cases. For releasing a stuck pipe, two things are necessary. First of all, you need to know what kind of stuck up it is differential or the other stuck ups which you mentioned, and we need to take a quick action. And in this case, you said that enzyme pill worked better than HSD, which is the conventional method. So any questions to him?
In well number 1, you said there were 6 attempts using HSD and
acid.
Yeah.
We have.
So this was the enzyme pill we have applied in 7th attempt or?
Enzyme is attempt in the 7th attempt.
Okay.
Previously we have done this HSD spotting several times, as well as the acid. We use also HCl acid too, but without any result. So we use enzyme in the 7th case, and it's successfully we remove the.
Okay, thank you.
Yeah, thanks, Imtiaz. I think you have presented very well. So my question to you is, this enzyme works in case of water-based fluid.
This works very well in the WBM, water-based.
Water-based fluid, but it won't work in oil-based.
We didn't actually we don't use the OBM in most of the onshore as well as the offshore assets of ONGC.
Okay.
So we don't have the data of this.
Okay, and second thing is it's a differential stuck. So how much delta you can understand it would be when the stuck has happened?
Stuck up has happened around 1200 psi in this scenario actually, and is one of the structure in Rokia. Is a very geological complex structure. Anurag sir has already known how Tripura is very geologically complex. I think it's very hard to drill in this. Even Assam is too. It's very hard to drill.
And formation is mostly sandstone.
Sandstone, yes.
Okay. Yeah. Thank you.
Excuse me, one question. Can we use this enzymes well in matrix acidization job to decrease the water cut in productions?
Actually, we don't have this data to decrease the water cut, but there is a possibility if we use it in this water cut. It's used in a Bombay offshore, I have already told, but
Okay.
I'm not involved in this. If
Okay.
you knew, but it's a good approach. I can let you know I can tell you the answer in later after I get the information.
Okay, one more thing. It is available in India or imported chemicals?
This is an imported chemical.
Import.
But it's based in India actually.
In base.
If the founder and this company is based in, all are Indians actually, but based in outside India.
Okay, can you share the specifications?
Yeah, we will share.
Okay, thank you, sir. Thank you. Thank you.
Thank you. Thank you, Imtiaz.
Thank you, Imtiaz. It was nice presentation. Now, third is presentation on application of IoT in reducing NPT and improving drilling operation efficiency by Mr. Dheeraj Kapoor, is from Halliburton. Mr. Dheeraj Kapoor worked in the Halliburton more than 11 years. He is expert in directional drilling and has hand-on experience, presently working in Halliburton as a drilling consultant. So I request Mr. Dheeraj Kapoor.
Good afternoon all. I am Dheeraj Kapoor from Halliburton Landmark India team. Today I am presenting a case study on application of Internet of Things in reducing the non-productive drilling time and also to improve the drilling operational efficiencies. It's our contents of first we will tell us what is NPT, what is IoT, then case study, then the conclusion. Basically, hydrocarbon resources play a vital role in mitigating the ever-growing global energy needs. The oil and gas industry spends millions of dollars in exploration and extraction of hydrocarbons. After exploration, the drilling of well is most time and capital consuming activity. Implementing Internet of Things in drilling activity can increase the efficiency of operation and increase the safety. So first, what is NPT? First question in our mind is what is NPT? NPT is defined as the time taken for any abnormal operation carried out as a result of failure or an event resulting in a drilling operation stopping. A significant share of the drilling cost is spent on recovering the losses due to NPT. The major causes of NPT are unplanned downhole operations, mechanical failures, wellbore instability, stuck pipe, drilling fluid issues, excessive time in tripping operations, well control events, and weather and environmental factors, and logistics delays and data and communication interruptions. So every companies, there is a problem in front of us is how to reduce the NPT. So what is IoT? IoT stands for Internet of Things. In simple terms, if we say IoT can be defined as a technology that can enable communication between devices and the cloud as well as between the devices themselves. IoT has the potential to benefit all the three sectors, upstream, midstream and downstream. Basically, we will discuss about here in upstream. In upstream, it helps in enhancing the exploration and drilling operation and to reducing the non-productive time. So what our project goals are? Today we will discuss our goals are to explore ways of reducing the NPT in drilling operations. Second one is to increase the drilling efficiency and to reduce the operating expenditures. Third one, we will discuss the applications of IoT in real-time well monitoring. So this is our case study. In this case study, we consider 4 wells. Well 1 is under IoT, well 2 is non-IoT wells. Okay, so in well 1, as you saw, this is the DVD curves. The well 1, actually both the wells are of same formation. They are nearby wells, are the same basin wells. The depth are almost same. So well 1 we consider under Internet of Things, well 2 drilled before considering IoT. So well 1 completed in around 70 to 75 days and the same well completed in around 120 days. So the difference between 120 days and 80 days is almost 40 days we saved. So the figure shows the DVD curves and compares the well plan and the actual plans. The flat line between in the graphs indicates the unwanted events between the drilling operations. This data also helps in determining the number of days taken in a single well. This is the second case study. In this, well 3 is under IoT and well 4 is non-IoT well. So well 3 we completed in 128 days and well 4 we completed in 145 days. There is a lot of difference between these two figures. The main difference is in well 3 we applied IoTs. So we also compares all these the 4 wells. In this we also these graphs shows how much time we reduced. Suppose in well number 1, which is under IoT, we reduced the tripping time. We reduced the tripping time from 12% to 9% and also reduced the rimming from 8% to 7%. Accordingly, the drilling percentage will increase in well number 1 from 70 to 76%. Accordingly, the well will complete it before number of days. As per the same well number 3 and well number 4, well number 3 is under IoT. Accordingly, the drilling efficiency in well number 3 is 69% and well 4 is 65%. Means we improve the drilling efficiency by 4%. And how we will improve the drilling efficiency? By reducing the tripping time, by reducing the rimming time. As you saw, the graph shows tripping time 19% in the well number 4, we reduced to 17.7%. And in rimming from 5% to 3.39%. Accordingly, the drilling time, drilling percentage is improving. Next, we also consider section wise. In this presentation we only discuss about 17.5 section. Rest all the section I discussed in our paper. So in 17.5 section, the bit trip counts we considered. In well number 1, the total bit trip counts are 3, and the same well number 2 we in 17.5 section we bit trip counts are 4. So we reduced 1 trip count with the use of IoT, and same well number 3 and well number 4 we reduce the trip counts by 11. Accordingly, the tripping hours we also reduced from 157 hours to 76 as we compare from well number 2 to well number 1, and also well number 4 to well number 3, the tripping hours also reduced from 389 to 216. Actually, the bit, wear and tear on the bit is important parameter in the optimizing the NPT and optimization of each of the drilling sections. So what we do, we will reduce the tripping time. Tripping time is major factor in completion the well before timing. So conclusion is, the NPT is a big issue in drilling operations. It reduces the operational efficiency and increases the operating expenditures. The use of IoT-based softwares like DSRT, RTV, this helps us to collect the precise data during each and every activity, and analyzing the data engineers can decisions to increase the operational efficiency. IoT can also help to reduce the NPT, but also help us in real-time well monitoring. Thank you.
Thanks, Dheeraj. I have an observation to make here.
Yes.
So while you gave data and you concluded that IoT is superior, but you didn't share how it is done. Which sensors you are using, how it is done. If I say that I have optimized my bit and because of that trip time has reduced, because of that ROP has increased, that will also achieve the same objective. So you have not shared what kind of sensors were there, what data you collected.
Actually, sir, we used a Halliburton software, RTV, real-time well engineering. What RTV did, RTV on the basis of past history, the software sets a benchmark value. On the basis of this benchmark value, suppose we monitored 7 to 8 2000 HP rigs. So the tripping time lowest they will find out. On the basis of this sets a benchmark value every quarter. Accordingly, they will reduce. We will push the rig team to reduce the tripping times. And one more feature in our RTV is bit wear prediction. Most of the times we saw rigs during the rigs maybe pull out of hole due to you say if there is a poor ROP, they will pull out the bit. But after pulling out the hole, we saw bit is in okay condition. So our RTV tell us how much bit life is spending. Accordingly, we will improve the drilling operational efficiency and reduce the NPT times and reduce the tripping times.
So any questions?
Yeah, it's an extension to what he asked. There are two parts to the tripping. One is the reducing number of trips, another is trip time. Reducing number of trips is okay, prediction by software. How does the trip time itself reduce because of the software? That's my query.
How much trip
How
times?
does the trip time itself reduce? That anyway you can do it,
yes,
even without the software.
Actually, what RTV is doing, RTV calculates a ILT, invisible loss time. As I said, it sets a benchmark value. On the basis of this benchmark value means they considers a lot of wells, past wells. Accordingly, RTV set a benchmark value. On the basis of this benchmark value, they will send say alerts. Means now tripping time is means 20 stands per hour, it's 30 stands per hour, like this. It tells us the alerts. Accordingly, we will push rig team to reduce these trip times. Accordingly, the tripping hours will reduced.
Hello. So I just wanted to ask one question. This you have shown is from the land operation?
Yes,
okay.
onshore.
Because in deep water operations, because of narrow margins, we cannot put pressure on the tripping speed.
Yes, yes, I understand.
So
This
otherwise we may land
is
into ballooning or losses.
Yes,
or
yes, I understand.
So
this is of onshore wells.
Okay, thank you.
My question is, you said Internet of Things IoT. So it is just only software or something is package of sensors?
Package of sensors. What Halliburton does, package of sensors we provided. We fetch data from all these sensors and analyze the data through data engineers. And we provide a lot of softwares like RTV, DSRT for monitoring. On the basis of this, data engineers analyze all the data. RTV, our drilling softwares, also sends us alerts if there is any anomalies or if there is any we will reduce the tripping times, how we will reduce the bit trips, how we will reduce the ILT times. Accordingly, they will send say alerts.
Okay. Yes, so I have a question.
Yes.
When you say IoT, so IoT is like you mean it is data transmission and then support by remote people like in RTOC, or there is some other algorithms also like machine learning, AI, data analytics you are using
Actually,
to optimize this, decision making?
This is the both. As you said, we will receive the data from our sensors, and our softwares like RTV, DSRT, and all the softwares. We already mentioned some the system, the artificial. There already some formulas are behind this. The softwares behind this. Accordingly, they will calculate.
Oh, those are legacy systems, or they are digital systems, mean next gen systems like machine
They are
learning?
digital
AI?
systems.
Digital systems. Okay. Thank you.
Can this predict stuck pipe prevention?
Yes, RTV can prevent stuck pipe prevention. It's there's a stuck pipe prevention module. It shows how much percentage of you say there's a chances of 10%, 20%. If there are more chances, after 10 to 15, 20%, it will send alerts to the assigned email addresses.
Thank you.
Thanks, Dheeraj. As you shared that IoT starts once the well planning is done. Once well planning and design is there, then you feed in this data to the IoT system, and then your sensors do several monitorings. They monitor vibrational data, drill bit condition, downhole temperature, rock characteristics. Then you make real-time changes in your well program, and then you achieve the desired objectives. Thank you so much.
Thank you.
Thank you, Mr. Dheeraj. Now, I would like to request session chair for their valuable comments and concluding remarks.
Thank you so much. This session was on advancements in drilling technology, and there were 3 papers which were presented here. And as we all know, oil drilling has been around for more than a century. The first oil well was drilled by Edwin Drake. It was in 1859, and it was drilled with the help of salt well drillers and blacksmith. And since then, technology has grown leaps and bounds. We have seen shale revolution with the help of MWD, horizontal drilling, and HF. We have seen huge technological advancements in offshore drilling, which help us with the help of superior ROAC. We can even go much deeper in offshore drilling. And some say that drilling technology has reached the level of becoming at par with space technology. So some of the papers were presented here. As we all know, it is the primary method for accessing underground hydrocarbon reserves, and it is critical to the discovery and development of oil and gas fields. Some of the digital tools we saw today, industry has been continuing digitizing drilling, which helps us reducing the number of days, therefore cost, and maintaining safety. Many initiatives have taken place in drilling processes, such as automating the drilling floors. Then machine learning is being used for safer and faster ROP. One paper we saw today also. ML also played a major role in maintenance programs, including predictive maintenance for a variety of items, including top drives, mud pumps, and power units, which result in 30 to 40% reduction in maintenance cost. And we hope this technology improvements will continue in times to come. Thank you.
A very good afternoon to all. On behalf of DGS Technical Committee, I would like to extend my heartfelt gratitude to Session Chair Sri Anurag Sharma Sir, former Director Onshore ONGC, for navigating us through the session and enlightening us throughout the deliberations. I would also like to thank the presenters for demonstrating the new technologies and the various case studies, which brings the efficiency in drilling operations. I would also like to thank the audience present here for their valuable interactions throughout the session. Now I would like to request session coordinator Sri Siddharth Kumar, CGM Production, to present the token of appreciation to session chair and the presenters. Please. To Mohammed Niaz, please. Imtiaz. Sorry. Mr. Dheeraj Kapoor. Mr. Satish Srinivasan. All the presenters are requested to have a group photograph, please. Thank you so much everyone for your active participation. Thank you.
अच्छा यहाँ से भी है वैसे तो मुझे लगता है कि
But किधर there is no place to put.
है ना सर इसमें है ना सर देखो यहाँ पे है
हाँ
यहाँ पे है
But how do you
जानेंगे सर यस सर आपका सी पोर्ट है नहीं है ना सर इधर भी लग जाता सी है ना यहाँ पीछे है ना पीछे ये वाला है ना हाँ
I don't know whether it works or not. This is
ओके ओके राइट
encryption मांगेगा. Okay, encrypt. You have to give this thing, no? हाँ.
ओके पासवर्ड
उधर निकाल दो.
Yes, yes. Came. Yes, great. Working fine. Yeah, let's have lunch. Otherwise, we will be in trouble only. All will finish their lunch and then. हेलो, यस यस, हाँ हाँ, ओहो, हाँ, ओके, व्हाट यू थिंक, व्हाट आपको क्या लग रहा है कि इज इट मसल पेन और कुछ फ्रैक्चर? ओके, हाँ, बट मुझे समझ में नहीं आ रहा है हाउ ही फेल डाउन कि शोल्डर और थाई। यस प्लीज गिव इट टू हिम। हाँ बताओ कैसे गिरे थे? तुम्हारा बैग से, खुद का बैग से गिरा? ये मेरा है।
क्या करना है इसमें?
प्रेजेंटेशन कॉपी करना है।
कौन सी वाली?
ये जो सेशन हो गया ना अभी।
सर ऐसे नहीं दे सकते सर अभी।
क्यों?
ऐसे प्रेजेंटेशन किसी को
नहीं,
नहीं।
मैं तो ऑर्गेनाइजर हूँ ना, मुझे यहाँ से फाइनल वाला लेना है।
सर वो अभी मैं उनको दूंगा, अपने जो सीनियर है उनको दूंगा।
आपका कौन है बोलिए?
शैलेंद्र जी।
हाँ,
शैलेंद्र।
सलंदर?
ये है ना उर्जा वर्ता।
अच्छा ठीक है, अच्छे तुम्हें बस से उठे चले जाओ।
कौन सी? चारों ना?
नहीं आप क्या आईटीडीसी किसके तरफ से?
हाँ आईटीडीसी की तरफ से सर।
हाँ तो मुझे यहाँ से फाइनल पीपीटी कॉपी करना
नहीं
है
ये
ना।
है, ये कोऑर्डिनेटर है इस सब का प्रेजेंट।
नहीं तो वो तो लास्ट में मिलेंगे ना सर आपको।
नहीं अभी लेना है ना, इसका रिपोर्ट बनाना है
मेरे को। तभी अभी मैं फ़ोन करके पूछता हूँ।
आप जल्दी फ़ोन कीजिए, मेरा और भी काम है।
आप मेरे से वहाँ पे ले लीजिए, मैं दे दूँगा आपको। मेरे से लेना, मैं दे दूँगा आपको।
देखो ये होगा नंबर 1, ये आईआईटी वाला 1, उनका आगे 1 लिख दो। एक नंबर, फिर आप दे दो आप रिलायंस वाला RIL भी लिखा है ना।
4 नंबर। ठीक।
Hello. Yeah, good afternoon. I request all of you to take take your seat, please. Good afternoon, everyone. I am Pankaj Gupta, GM Production from DGH. Now we are going to start one interesting session on decommissioning best practices. So everyone knows that after post-lunch sessions are very difficult to concentrate, but the topic is very interesting. It's a futuristic topic because a lot of our fields are going to mature and shall be completing their productive life. So this decommissioning will be very useful in future. So from futuristic point of view, this session is going to be very interesting. So the session chair is Mr. T.K. Sengupta. And now, not taking much time, I invite Mr. T.K. Sengupta to chair the session. So let me give you a brief about Mr. Sengupta. Mr. Sengupta is an E&P professional with over 43 years of experience in E&P industry. He served ONGC for 37 years and retired as Director Offshore in 2017. He also served as Director E&P in FIPI from 18 to 23 for 5 years. Presently, he is working as advisor with Sun Petro. He is basically first-class chemical engineer from Jadavpur University, Calcutta. And he has also got certification course from ISM Dhanbad. He is associated with onshore and offshore both type of operations. In offshore, he has worked in AMH, Neelamhira, B&S, and EOA. He has also worked in OVL in Nile Ganga, Greater Nile Petroleum Operation Company for 4 years in Sudan. In next 5 years of his stint at FIPI, he has developed a platform for advocacy and policy framework on behalf of the industry to take up the DGH, MOPNG, and Niti Aayog. He has authored several technical papers and delivered talks in most of the national and international conferences organized by SP and others. He continues to be actively associated with the Society of Petroleum Engineers. SP has acknowledged his contributions and recognized him as a distinguished member in 2012. He is also associated with different industry inquiry committees, expert committees, and advisory committees. Over to you, sir. Thank you, sir.
Thank you, Pankaj. Good afternoon, everybody. I hope that, as Pankaj has said, that it's a very, I think, challenging session post-lunch. And I think the speakers and this session will try to keep all of you as much awake as possible, because there will be a lot of, I think, noisy sound, because decommissioning will take place. So decommissioning is something different. So you all know what is decommissioning. That is the last activity of a life cycle of production of oil and gas. When the reservoir gets depleted or it comes down to the scale where further production or injection is not possible, the standard procedure is from the sustainable resource management and the environmental stewardship or environmental leadership that you need to decommissioning those structures, the pipelines, wells, everything, especially in offshore. So we will be, I think, talking mostly, our speakers also will be talking on the decommissioning of platforms and pipelines in offshore condition, on offshore environment. The most, I think, complex thing is that the entire decommissioning process. It is having an essence of everything present in a decommissioning, because it's the reverse of a commissioning of a new developed offshore field. So when you are going to adapt a decommissioning system, starting from the well abandonment, plugging and abandonment, your removal of the jackets, risers, platform, pipelines, pipeline to be loaded with nitrogen, the entire project planning, project execution, lot of engineering and planning, regulatory framework, HSSE, everything comes under that big thing. So I think it's a very well thought of planning you need to do for decommissioning. As per IHS report, maybe a couple of years before, 3-4 years before, I read somewhere that in the world, around 2,000 offshore structures are ready for decommissioning activity till 2040. And majority of them in the North Sea and in the Southeast Asia. Unfortunately, in India, majority of the offshore structures belong to ONGC. And we, as former ONGC employees, we know, we have worked in offshore. A lot of my colleagues are here. We know there are a lot of structures which can be abandoned, which can be decommissioned. It will save the OPEX of maintaining those platforms because they have lived their life, and the intent of those platforms have gone because of low injection or no production. But there are some regulatory areas which is a stumbling block at this point of time, and hopefully those also will be removed over a period of time. The only field which is under decommissioning, that is Tapti. It was under a joint venture Panna Mukta Tapti scheme operated by BGEIPL, now it's Shell. And so that was in the last stage of the decommissioning. We'll hear the story of that beautiful story in the first decommissioning scenario in India, and the challenges and the lessons learned from our speakers. So this session we are having 4 speakers. They are all industry expert in their own line, and representing the best of the companies at this point of time. And I hope they have brought their experiences, their knowledge, their company work which they are doing not only in India but also abroad, and good regulatory policies, which is also very, very important, because without a strong regulatory policy, this kind of high capex project is not possible. It's a very, very important thing. The way we are doing a new development offshore project, where a lot of capex is required, billions of dollars. There we know that we are going to gain oil and gas, because that's what the intent of that platform. But when we are decommissioning, it's basically the 2 things which I have mentioned in the beginning: the sustainable resource management and the environmental stewardship. These are the 2 things for which actually a company is doing, or a set of companies are doing. So with that boundary, I have to introduce my speaker. What I will do, I will introduce one speaker at one time, and I will request him to take up take up the podium to deliver his speech. So our first speaker is Mr. Raja Gopal Mahalingam. Raja Gopal is most of the industry members. They please come. They know him very well. He is the decommissioning man of India right now. You can give him a big hand. Because 2015, when the idea was floated by Shell of Tapti decommissioning, fortunately or unfortunately, I was director offshore of ONGC, and we are having a 40% stake there. So from that day, it is 9 years. He is with the decommissioning the project, and he will see that it gets completed successfully. So with that small introduction, I hand over to Raja for his presentation, and just let us know what is happening there. Thank you.
Thank you, Sen Gupta ji.
You have got 8 minutes time.
Okay. Thanks a lot. In the first instance, I would like to thank DGH and for giving me the opportunity to present our experience in the decommissioning space. As Mr. Sen Gupta ji mentioned that I'll just go through all the slides because he has already told me there are 8 minutes. I'll start. We happens to be the first joint venture on the block in carrying out the decommissioning in India. The decommissioning industry, if you see globally, is well matured in the Gulf of Mexico and North Sea. And in terms of the volume of work, in terms of the quantum and the size of the industry, it is pretty sizable, and it is projected and forecasted to double in the next in the next decade or so. So there is significant potential, and if you see the Asia Pacific contribution is also increasing going forward in the coming decade. Under this context, when the joint venture set herself at the task of going ahead with the decommissioning, when we realized that we had to decommissioning the facilities, we found that the framework existing in the country was very rudimentary. We just had a PSC which put the obligations on the joint venture, and the requirement asked us to conform to IMO requirements and not very detailing. So we had to go through quite a bit of collaborative work with the regulators and the MOPNG in terms of setting up the framework for carrying out the decommissioning plan, and then going ahead and executing that. I will not get into the detail, but because I have my subsequent speaker, Mr. Keshav, who will get into what the regulatory requirements are, what the framework was, and what the evolution has been. This is one of the earliest activities which the joint venture had to do, set the framework rightly, and then we had to open up the kite. As in any project space, we were in the assess stage. I will take you through all the stages. In the assess stage, we had to open up the kite, ensure that all the options are on the table for finalizing the decommissioning plan. All the data and the framework which are required for evaluating each of these options are there in place. That required quite a bit of collaborations with the regulators, with not just the MOPNG and DGH. There are many other multiple regulators like Department of Fisheries, Ministry of Environment, Ministry of Defense. So across the spectrum, we had to go across, collaborate with them, explain and sensitize them to their relationship to the decommissioning. For each of them, it was a new space. It required quite a bit of engagement with them. So that was the front end work which he had to do initially in setting up, going through the assess stage. Which that in place, then we went about screening the various options which we had opened up in the early stages under a very globally utilized best practices of comparative assessment. So this comparative assessment requires us to set the criteria under this objective assessment. These criteria were safety, environment, societal, technology, and economics. And these criteria set in place, we had the regulators and the other government agencies participate in an assessment workshop. So in the first instance, we had to bring about a significant change in the mindset from an auditing mindset to a collaborative mindset amongst the regulators and the external stakeholders. That was a good journey, significant journey that eased our process of getting the decommissioning plan approved. And as you can see in those charts which are there, those are the outputs of the comparative assessment workshops which we did, where we assigned weightages for each of those criteria and did the scoring. And the one with the lower score won. And accordingly, we agreed on a decommissioning plan which required us to decommission, remove the jackets and the top sides and get them decommissioned and dismantled at the yard. What needs to be known here is globally, we did find that the option which comes out as a winner is a rig to reef option. In our instance, if you see that this did not come out as a winner, that was an eye-opener for us. While it was a concern even before we did the comparative assessment, we had some challenges. I would like to take this August forum through those challenges, and I'll be looking out for the regulators, representatives who are in this forum to specifically note this. There is a scope here for us to really improve and make things easy for the other operators when they go in for decommissioning. Rig to reef, the challenges, why did we not score well on the rig to reef? Why did it not come out as an option? The reasons were primarily at two levels. One is we were struggling to find a central repository of information to identify the reefing locations in the East Coast and West Coast. We did not have that identified. Department of Fisheries happens to be a state subject, and so the informations are spread across among the states, though it comes under the Ministry of Environment. The informations are spread across it. And even then, we did reach out to various state bodies. That information in its form is not existing. So that was the thing. And the other one is there is no regulatory framework which is existing. Whereas in Gulf of Mexico and in North Sea, we have a clear regulatory framework under which they can reef these were the two things. And that will be something we should actively look at bringing in place so that other operators look at. For example, Malaysia, the default means is rig to reef. The next is, having done the select, some of the front-end activities which we should be doing for really capturing the value is that we should try to eliminate the hydrocarbon risk as early as possible. In terms of safety, it brings us about value. In terms of cost, because the facilities which are required for eliminating the hydrocarbons will cease to function at a later stages in terms of process platforms, in terms of the vessels which are available for carrying out. These are available during the operating phase, so those will cease to exist. So we should try to carry out those evacuation and elimination of hydrocarbon at a very early stage. And also we should try to collect as much data as possible. That is one of the value-adding front-end activities in a decommissioning space. Collect as much data as possible, as much as-built information which is possible. That eliminates significant risk to whoever the removal contractor who comes about at a later stage. In terms of maturing the supply chain, the two critical activities are, one is offshore removal, that is heavy lift vessel. You can bring them from Southeast Asia, Middle East or any Far East, it's much more easier. But the yard where you want to dismantle and dispose it off, that needs to be in country. That's where you add value, and cross-border shifting of scraps is a very cumbersome work. You have to conform to Basel conventions and regulatory requirements are very stringent. So we need to develop the supply chain. For that, we have been able to develop a yard over the last few years, and I think that work should be going on quite a bit. We have multiple options. In terms of the contracting strategy, I would say that there are 4 definitive options which are there. The building blocks are the end of field life operation. That itself is different from operating the field in its normal life. And the next one is well P&A, EPR and DY. So there is different means of mix and matches, and there are different value addition due to each of them. Well, we as an operator, considering the regulatory framework we have today and the maturity we have in the industry as existing, we had to adopt where the end of field life was managed by joint venture, and then we had to let out the well P&A under a separate contract, and the offshore removal under a separate contract, and the dismantling under a separate contract. But that said, there are value additions in looking at various other models which will bring value to other operators, and if the market matures and the regulatory framework does allow that. And well P&A, I would not go into much detail, that is not my forte, but we did adopt, it was a very simplistic one because we don't have any multilaterals, we did not have highly deviated wells, we just had to plug at 2 levels, and then and there's environmental plugging. It was very simple, I would say. In terms of efficient execution, I think what we should do is use the industry standards as much as possible. It should be a risk-based definition, no prescriptive ones, and try to give maximum flexibility to the contractor, define the what of it, how to do it, leave it to the contractor. He is best placed to define it. And be pretty open on the terms and conditions. It may look as a reverse of installation, but it's very different. So terms and conditions should be more flexible and bespoke for the decommissioning world, and not, we should not transfer a developmental terms and conditions for a decommissioning project.
You have to sum up.
Yes. So that, to sum up, change the mindset, never think of decommissioning as a reverse of development project. It is pretty unique in itself. It has its own challenges, and start with that mindset. Use a very fit-for-purpose DNR requirements. Don't be so elaborative. We are not building any facilities which is going to live for 20, 25 years. We are not looking at a project which has got a revenue at the end of it. Be flexible on your timelines. So those are things. Learn from other countries. That's something which we have done till now. We have brought in the facilitators from other countries, and we looked at North Sea, Far East, and Gulf of Mexico, and the regulation as stand now brings the best of all of that. A very collaborative environment. The stakeholders are much more wide from a development project. We have to look at the after users of SRI, probably Department of Fisheries, Defense, shipping industry. All of them have to be brought together and collaborated in coming up to the best decommissioning plan. And be innovative in your supply chain and adopt the right contracting strategy. There are many ways of doing it. There is no right way of doing it. Circumstances and the working environment and the maturity will define it. And look at campaign bundling, look at cooperation among the operators. The biggest cost is the heavy lift. If you can collaborate amongst the operators, even amongst the countries, I think the cost can be significantly reduced. Use the right technology and be innovative and for safe operation. I have to be like Shankar Mahadevan in Breathless.
Thank you very much. I can take 1 or 2 questions maximum. Be very brief, and you can ask to the speaker. Anyone? There is a hand raised in the back.
No, thanks for the quick run through of the decommissioning process. But in terms of DNR, you said that you took a simplified approach, etc. All that's fine. But what is the regulation for ensuring that there is no leakage through any unknown pathways that can happen in the future, despite putting your 2 plugs in the well? Is there any regulatory framework that you had to follow?
Yeah, okay. This is a good question. Globally, the practice is that there has to be a survey every 5 years. Survey needs to be done. That is the global practice. But that mandatory requirement has still not come into force in the Indian context.
Yeah.
Survey of the well after you abandon
it? The global regulation requires anything left inside too has to be surveyed. It's just not the wells. For example, in our instance, we are going to leave the pipeline also in situ. So even those needs to be surveyed. That's what the global practice says. But in the Indian context, it doesn't exist as of now.
Yeah, but there will be piles that will be left behind, or any subsea platform.
Pipelines will be left behind. Yeah. So those also to be surveyed in the global context. In the Indian context, the requirement states that you have to establish the stability of the pipeline by means of engineering analysis, and then we need to carry out a survey one season after the actual decommissioning has been done to establish that the pipeline is stable and has not moved from its original space. And that absolves the operator of his responsibilities and liabilities. That's how the regulation exists as on date.
Okay, thank you, Raja, for a wonderful presentation. And if you please come to your. Thank you very much. Give a big hand to Mr. Raja. Our next speaker is Mr. Gurjit Singh. Yeah, please come. He is from Oceaneering, and he is having almost 12 plus years experience in offshore decommissioning all over the world. So I understand that he will take us to some of the case histories internationally where Oceaneering has taken part in decommissioning of some big project. Over to you.
Thank you, DGH, for this opportunity to speak at this forum. So today I'm here on our session for decommissioning best practices, particularly focusing on the decommissioning of floating structures. So here I will be referring to one of the project examples that we did recently in Black Sea, Georgia. So, but before I start on that particular example, so the biggest risks of any decommissioning projects are hydrocarbon leaks, and hydrocarbon leak to the environment should be minimal. And then the second biggest risk is that there should be safe handling of the assets, because those assets are going to be decommissioned, they are at the end of their service life. So there will be a lot of risk if the proper precautions or let's say proper inspections are not taken, have not taken in this initial phase. So while talking about that, I'll just explain the approach, the methodology and achieved outcomes, and the potential validation that we did in that particular project in Georgia, and then the lessons and major takeaways from that project. So talking about the approach first. So in any decommissioning project, I believe first and foremost thing that has to be done is the comprehensive field study. You need to know the complete field in and inside out. So what's there upstream, what's there downstream, how it impacts, what would be the shutdown duration, how much execution window we have, and we have to respect that window because it impacts costs ultimately. So in this particular case, you can see we decommissioned 250-ton calm buoy, which was a kind of floating structure in the Black Sea, Georgia. And just to focus over here, this region was specifically, this happened specifically during the time when we were having that Russia-Ukraine war conflict. So there was a lot of safety risk at that point in that region. So we had special mine watch vessels during our entire offshore execution. And then as it's mentioned, so this calm buoy structure, it's comprised of 2 floating hoses, 2 subsea hoses, and then it was held in place by the mooring chains and the mooring anchors. So we had to make a complete field study where this existing structure is, and then we have to make sure that we have complete data on that. Now talking about the field study further, so we had to do the complete valve inspection because like I mentioned, the most biggest risk is the hydrocarbon leak to the environment. So we had to make sure that we are having the required barriers in place. So we did the complete study on the onshore side, on the offshore side, and we identified the possible locations where we could barrier. And as you can see in that picture, so the first barrier that we identified, the primary barrier, was the landfall valve, because the valves that we have on the subsea manifold, they were not in good condition. So that we came across when we observed the past operation data, the maintenance data. So it was observed that those valves were still leaking even in closed conditions. So we couldn't do any kind of flushing from, while considering those valves as our primary barrier. So we had to consider that landfall valve as our primary barrier. And then we still considered secondary barriers at the back of it, just to have extra safety, and then that's how the field study was done. Now talking about the methodology for flushing, so there were 2 lines that had to be flushed completely because we were having the 2 floating hoses that were connected to the tankers. So we connected the first line to the flushing vessel, from where we flushed 3 line volumes of the fluid, and we parked, and then once we had the cleanliness confirmation, so for that we took samples on the calm buoy itself, and we did the tests on those samples, and then once we were sure that those samples are good enough, and then we parked the gel across the flange. So with that, we were sure that now this line is free of the hydrocarbons. So then we just closed that line 1 valve, and then we switched on to the second line and repeated the same procedure. So this particular line shows that the flushing that we did with the similar methodology on the second line as well, closing the valve on the first line, so that whatever flushing we are doing on the second line, it doesn't move back the hydrocarbons to the line 1. So then after the flushing, we were completely sure that there will be no hydrocarbon leaks on disconnection of any of the hoses. So then we identified the sequence, okay, because we are having multiple assets there, so what would be the disconnection sequence? So we started with the floating hoses first, because we wanted to clear the offshore area as much as possible for the free movement of the vessels all around. So we disconnected the floating hose, and then even for doing that, we had to identify a proper point for disconnection. Where should we disconnect? Whether the disconnection point should be subsea or it should be on the buoy itself. So we decided to go with the buoy disconnection at the gooseneck, eliminating the least time for the divers subsea. So we tried to do that on the top side. And then we did the disconnection for the submarine hoses. Now, for the disconnection of submarine hoses, it's not just a simple disconnection at the flanges, so we had to release the tension in those lines first. So for that, we deployed the clump weight, we let that settle on the bottom, and then that released the tension basically in those lines. And then we did the disconnection for those submarine hoses. So this particular slide shows basically the disconnection sequence, where we lowered the clump weight, we connected that with the mid-water buoyancy tank. So this mid-water buoyancy tank is nothing but buoyancy tank which was used to create that tension in those lines subsea. So for disconnecting this mid-water buoyancy tank, we had to do a proper checks on the pad eyes, the lifting points of these tanks, so that there is no incident or anything when we are trying to put any load on those pad eyes. And then followed by the submarine hoses. So we first did the disconnection at the plem, and then we did at the disconnection at the calm buoy itself. Now these pictures actually show the cutting that we did at the plem and the mid-water buoyancy tank. This picture then shows, then once the hoses are out of the picture, then we disconnected, we recovered the mid-water buoyancy tank itself, and that had to be kind of a tandem lift between the clump weight and the buoyancy tank, because buoyancy tank is otherwise a missile coming from the water, and it can hit any vessel or it can be a major incident. So that had to be a very controlled operation, critical operation, which we had to do in tandem, in controlled manner. Then we did the disconnection for the mooring chains. Again, the mooring chains were quite heavy, quite long, 380 meter long each mooring chain. So we had to make sure that we release the tension in these chains as well. So we passed the messenger line through the chain lockers on the calm buoys itself, and then we also connected the chains with the anchor handling tugs, releasing the tension in those chains, and then we were able to do the disconnection from the chain locker itself. And in this particular scenario, the disconnection sequence was again very important, because there are 6 mooring chains, and we had to make sure that we are not letting the calm buoy set free in the offshore waters. So we had to disconnect them in a particular sequence, taking care of the weather consideration. So as mentioned, so weather limitations are definitely a big challenge if we have to consider any of the offshore operations, whether it's towing operation, it's air diving, it's sat diving, or even if it's anchor chain operations. So one particular example, we had to set the proper weather windows for that. If we are doing any operations, so on air diving, we had a swell limitation of 1.2 to 1.5 meters, which we had set based on the area geography. And then if we talk about the potential value addition, so we had 185,000 working hours without any major incidents or any hydrocarbon leaks or release to the environment. So that was a big win for us in the project. And then afterwards, we were able to achieve this with the integrated approach. We were having the diving services, the ROV services, the complete vessel fleet, the complete project management and engineering. All of that we did by ourselves. And on top of it, we had the experienced workforce, because we had done similar calm buoy decommissioning in West Africa as well before that. So we were able to replicate the same in Georgia with good success and without any accidents. Major takeaways from this project: we did a very extensive project planning, and then we had a contingency option. We had prepared backup plans for different options. Let's say if the weather picks up, or if let's say the current direction changes, so then we have to alter our disconnection sequence. So we were already having the contingency planning for that. And then we also had a check on the weather window. It was not only in the initial engineering phase, we also did that during the operations, doing a regular check on the weather forecast. And then for any decommissioning project, any recovered items from the offshore has to be checked for norm. So that was also something which we took into picture. Now I will also just sum up the business segments that where oceaneering operates. Yes. So we have got subsea robotics, we've got operation projects group, offshore projects group, and we got manufactured products. So several of our products are being used in industry for different operations, different activities. We've got IMDS and we've got aerospace and defense technologies as well. Now talking about the business and operations in India, we've got 4 offices with Mumbai, Kakinada, Pune and Chandigarh. And our remotely operated vehicles, they have several rigs in India. And the deepest dive that we have done is 3 kilometers for ONGC in June 2013. We also provide subsea field vessels and have supplied our products to refinery plants. So with that, I'll open the floor for questions.
Thank you, Gurjot, for a wonderful presentation on decommissioning of a floating structure. So that's quite new. Some of our operators are having floating structures. They may be thinking of decommissioning it in future days to come. So house is open. Very quick questions, 1 or 2.
Yes, please.
Yeah. Yeah, it was a very nice presentation. I have a question like, who was the insurer for these total activities? And
so we had got this checked and insured by ABS. So ABS was appointed from client side. So we got all that insured from ABS.
But ABS is MWS, right? Marine Warranty Survey.
So I think that's what I know, but I let project manager, he is also here with us, Mahesh Kandge, he can elaborate on this answer a bit more.
Yeah. Okay. Okay. And any QA/QC agency was there to take care of the total activities?
From the operator side as well as from the oceaneering side, we have our internal QA/QC. Yeah.
Okay. Yeah. Thank you.
Thank you.
Any questions further?
Yes, please.
Yes.
That you had on the line, that was existing?
Yes, those were the existing valves.
Okay, thank you, Gurjot.
Okay.
Give a
Thank you,
big hand to
everyone.
Gurjit for a wonderful presentation. Our next presenter is Amit Jain. Amit is from ONGC Institute of Production, Engineering and Ocean Technology. So he is working with the structures, offshore structures, for a very long time, and will be taking us to the decommissioning philosophies of ONGC and the way they are strategizing the future decommissioning in the country. Over to Amit.
Yeah, thank you, sir. Yeah, good afternoon, everyone. Sir has already introduced me. So in this presentation, we will be discussing about various decommissioning practices in context with Indian offshore. Yeah, this is the presentation outline covering introduction, decommissioning need, its procedures, various practices, global regulatory framework, and application in Indian scenario. Presently, ONGC is operating with more than 330 fixed offshore platforms in western offshore of India. These platforms are supported by lattice type steel tubular structure that you can see here, like pointer. This is the jacket structure we call. So these platforms are supported by lattice type steel tubular structures installed in water depth ranging from 20 meters to 80 meters. These platforms are secured to seabed by steel tubular pile foundation, which are driven below seabed up to the depth of 80 meters to 120 meters, depending on the soil condition prevailing at that area. Typically, these platforms are designed for a service life of 25 years. More than 2/3 of ONGC production comes from the Indian Western offshore. As of now, more than 50% of these platforms have surpassed their design lives. So, and as an operator, we will continue to use these structures as long as they remain safe and economical to operate. But certainly, a day will come when maintaining these structures or these platforms will become uneconomical. And then we may have to go for the decommissioning of these platforms. So first of all, let's discuss why decommissioning, what are the factors affecting the decommissioning. First one, as I just discussed, matured and depleting fields which are no more economical to operate may lead to decommissioning and abandonment. Second one is aged infrastructure which is not fit to operate, no longer safe. Deteriorated pipeline networks have to be decommissioned. Another factor is oil and gas pricing. Another one, advancement in decommissioning technology. And the last one is switching to green energy. So all these factors may lead to decommissioning of hydrocarbon producing infrastructure. Decommissioning procedure starts with engineering and planning phase, which itself involves 5 to 8% of the total cost of decommissioning project. Poor planning may lead to higher cost in decommissioning, very high, huge expenditure. Second stage is to submit the decommissioning plan to regulatory authorities for approval, then inspection of the site, followed by most crucial well P&A, which involves around 45 to 50% of the total cost, and then followed by this conductor removal. These conductors are removed by cutting 5 meters below the seabed, and then topside preparation, decontamination, and then pipeline flushing, abandonment, topside removal and disposal, and followed by substructure removal and disposal. At last, decommissioning activity completes with site clearance and restoration of marine environment. So one of the practice involves the complete removal of the structure. Like in this process, the entire structure is removed from the seabed and transported to the shore for disposal or recycling. Another practice is rig to reef, like this, where offshore structures are cut from the seabed, either whole or in parts, and placed at the designated location for artificial reefing. These artificial reefs provides a habitat for marine life, enhancing the local ecosystem and contributing to biodiversity. The third practice involves the alternate use of the structure by replacing the topside with a wind turbine or another renewable source of energy or device. So with time, world has shifted its stringent regulations to the practical ones, keeping in view of marine environment. So initially it started with 1958 Geneva Convention with complete removal. They said that you have to abandon the platform fully. In 1972, regulations allowed toppling and artificial reefing of the structure. And then in 1982, regulations permitted partial removal to provide artificial home to the marine species and emphasized to form globally acceptable guidelines. And then in line with this, in 1989, IMO guidelines were developed, allowed partial removal for structures, but partial removal for having weight more than 4,000 tons and placed in the water depth more than 75 meters, with leaving clear draft of 55 meters for navigation safety. Later on, 1982 OSPAR convention came and OSPAR 98/3 came with stringent regulations. It prohibited any kind of dumping in sea excluding pipelines. Pipelines can be left behind, and gravity structures, very huge structures, so decommissioning cost is very high for those structures, and structures having weight more than 10,000 tons. So then came 1996 London Protocol, an updated version of this 1972 London Convention, which developed guidelines for artificial reefing as well. So now coming to Indian scenario. Tapti offshore decommissioning project is already discussed, is the first of Indian offshore region. It includes total 5 platforms and intra-field connected pipelines to be decommissioned. This project is executed by L&T in compliance with guidelines issued by domestic regulators like OISD, DGH. During the planning and engineering, operator can choose rigless or rig-based P&A, can explore the possibility of alternate use or reuse of the structure, can make cost comparison of onshore disposal with the artificial reefing, and globally acceptable guidelines are to be followed with due cognizance of domestic regulatory authorities and site specification guidelines to be framed in Indian context. To make the supply chain management more robust in the decommissioning Indian scenario, these are the various factors, like Rajalingam sir also told, these are the various aspects where industry can work further in future. And at the end, financing of the decommissioning project as well as its accurate cost estimation is very much crucial. Utilization of site registration fund would play a very significant role in this aspect. So with this, I conclude my presentation. Thank you very much.
Yeah, thank you, Amit, for a very comprehensive presentation on the different rules, regulations, and in Indian scenario, especially the activities. So the house is open for questions.
Yeah, yes, I want to ask a question. Do you have any site registration fund in ONGC? Or second question is, any plan, anything learned from the Shell experience, any planning you're doing right away? Because Shell has taken a long time. So any planning is there in ONGC for any platforms or anything?
Yes, sir. As per my knowledge and information, we do have the site registration fund in ONGC with the DGS basically. As per the Indian government scenario, the regulations, the fund has to be kept with DGH. So DGH is having
the older
yes. DGH is having the funds of ONGC as per my information. And for in future decommissioning of any platforms, actually the thing is, if you go for the single platform decommissioning, it would cost more. So you have to wait for some 4 to 5 or 10 to 15 platforms to be grouped and proposed for the decommissioning. Because mob debob cost is very high in these aspects, the vessel cost is very high. So if you have n number of platforms, your decommissioning cost will reduce. So
any plans are there or not as of now?
Right now we do not have any such kind of platform, so we do not have the such decommissioning plans in near future.
Based on my knowledge, this SANA fund is being maintained by MOPNG, the guideline of Ministry of Petroleum and Natural Gas. We ONGC has opened account with SBI. We have around 3,000 crore fund available with SBI, but we are not able to use, because you see the guideline says that unless you abandon the
Complete field. Actually, the problem is there.
So we are requesting to allow partial withdrawal of fund, but I think there is some restriction.
So that is the bone of contention with the government. So that discussion is going on.
Yes.
Any other questions other than this aspect? Yeah.
Yes, definitely.
Technically, there are a lot of.
Yeah, actually, technically, many things are there. Now you cannot go for one platform. So.
I retired from ONGC and I was the instrumental in both the decommissioning
Yeah.
So I'm asking, we should move fast.
Definitely. But still, there is a time. We are still exploring and exploiting from the western offshore. So
in that context, I'd just like to highlight the global. What is a global practice? There is an idle iron regulation, which says that any facilities, if it is idle without producing for more than 5 years, it needs to be decommissioned and removed from site. That is the global requirement.
Global regulation.
That has not come into place in India. At some point, I think Indian regulators have to look at that. Otherwise, we will have similar situation like Katrina, hurricane. We had structures getting lost and toppled. So otherwise, we'll be faced with some risk.
It's an eye opener for everyone, sir.
Okay, we had a very good, healthy discussion on this issue, and I think a lot of queries are cleared. So thank you, Amit.
Thank you, sir.
For igniting all of us. Our next and the last presenter is Keshav Vaishya. He is from DGH, and what we are discussing exactly, Keshav will bring some of the thoughts, I hope. It's because he is from DGH, he is the regulator, he is our government. So from policy and regulatory framework issue, he will be giving us some of the thought process which is going on. Over to Keshav.
Thank you, sir. Good afternoon, everyone. Today, I would like to present a policy framework decommissioning in India. In my presentation, I will cover the site restoration guidelines, decommissioning projects in India, and challenges faced during the implementation The foundation of site restoration and abandonment lies with the Oil Field Act, which is also called ORD Act 1948, which governs the oil field development and regulation in India. Subsequently, the petroleum and natural gas rule were introduced in 1959, which imposes decommissioning obligation to the contractor, according to the Rule 22 of the PNG Rule 1959. And this rule also need decommissioning plan to be approved by the government. And according to the building upon the ORD Act, government enacted PNG Safety in Offshore Operation Rule in 2008. According to this Rule 12, decommissioning plan required to submit and get approval from Oil Industry Safety Directorate, outlining the project risks, methodologies, risk analysis, removal consequences, and adherence to the IMO guidelines. The decommissioning project shall comply the laws of India, environmental regulations. Recognizing the high costs associated with site restoration, often incurred during the non-revenue generating period, the government introduced Site Restoration Fund Scheme in 1909. The scheme linked to the Income Tax Act, incentivizing contractors to allowing them to allocate 20% of their profit towards the fund. The Site Restoration Fund 1919 was helpful, had a limitation. In 2018, government with consultation with industry introduced Site Restoration and Abandonment Guidelines. These guidelines provided clear modalities for establishing Site Restoration Fund, including deposit amount and modalities for withdrawal. The SRA guidelines in 2018 were amended in 2021, which is known as Amendment of Guidelines of Site Restoration and Abandonment. Guideline for creation of Site Restoration Fund. Site Restoration Fund to be created immediately after first oil and gas production. Presently, in India, have two designated branches of State Bank of India. One is Telbhavan, Dehradun, and another is Egmore branch in Chennai, having the facility of creation of site restoration account. Busy submission for after the first initial oil production, you have to create the SRF account, but you can alternatively submit bank guarantee for initial 3 years. And this, due to the varying life of asset, the site restoration estimate to be carried out every 3 years by the independent third party. And based on this amount, the estimation, site restoration fund to be deposited. The amount to be deposited is linked to the reserve to fill ratio, reserve to production fill ratio. For instance, if a field has produced 20% of the reserve, then the site restoration fund should have the 20% of the estimated amount after a particular year. As I mentioned, the site restoration guideline was amended in 2021 to address some practicalities. The amendment acknowledges the financial burden of upfront contribution. For new field and existing fields, contractor can alternatively submit BG and the amounting 75% and remaining 25% amount to be deposited in site restoration fund. And this percentage is reduced to 50% from 5th year onwards. This amendment provides a financial flexibility for contractors, particularly in initial stages production when the cash flow might be very low. It allows them to spread the financial burden of decommissioning over a period of time. This is the process for decommissioning, process for decommissioning of site restoration and abandonment as per the 2018 guidelines. initially you have to be submit a schedule to MC6 work program and budget for is approval of studies of site restoration. Then the MC concurrence and carry out appraisal study towards the development of abandonment plan. Then after the cessation of production, the proposal to submit to OISD for approval. After OISD approval, seek MC approval for abandonment plan and work program and budget, and carry out abandonment activities as per the abandonment plan. Now we shift to gear the withdrawal site restoration fund. The para 8 of site restoration fund 99, the expenditure towards the site restoration activity is allowed to withdraw after the expiry of contract or relinquishment of area or part relinquishment of area. Because of these rules, ONGC is unable to withdraw from site restoration fund scheme for abandonment at this time. So 2018 guideline provide the mechanism for withdrawal. For withdrawal, following requirements: approve work program budget, and then the work program budget to be approved by MC, then submission of Form E that is available in 99 guideline, duly signed by the contractor. Then with this, contractor has to submit utilization certificate. The utilization certificate is duly accessed by third party auditor, and the process of withdrawal is that the 75% of the fund must be used for the last withdrawal and 100% for all the previous withdrawal. And after the site restoration, if any balance amount is available, then it deal with the PSC provisions. So decommissioning project in India, that is CBONN 2002/2 Nail Block with Bhima Field. This is the first decommissioning project in India which is funded by Site Restoration Fund. Project executed under Nico Resource Limited, and the cessation of the field occurred in November 2012. Total 12 wells and associated facilities were decommissioned, and site restoration is completed in February 2016. This is the site figure is the Tapti field, and the blue line is the Part A facility, and the line marked with orange color is Part B facility. Part A facility is transferred to ONGC for processing of nearby gas field, and Part B facility is under execution. This is a first offshore project in India. The project is executed under JV having 30% PI of SAIL and the Reliance and 40% ONGC. The field has seized in March 2016. Total 38 wells abandoned in 2018, and Part B facilities under abandonment. The project has to be completed by the end of the 2021. Due to COVID-19 and other some issues of getting specific period license, the project got delayed, and last year the project got delayed one more year because of the non-readiness of the decommissioning yard. Hopefully this project offshore decommissioning will be completed by end of this financial year, and I am looking after coordinating from DGS with PMT-JB regarding the getting regulatory documents. We have a challenges in decommissioning. Decommissioning is very nascent in India. Many offshore facilities and are old and need replacement. Limited availability of decommissioning services, especially in dismantling and disposal yards. And another issue is partial decommissioning and plug and abandonment of wells are require partial relinquishment of the area for site restoration withdrawal. If the partial area is not relinquished under site restoration and fund scheme 99, withdrawal from site restoration is not allowed. And ONGC is requesting for several times for modification for this rule. By acknowledging these challenges and implementing strategic solution, India can ensure a smooth transition towards a more mature and efficient decommissioning industry. Thank you, sir.
Yeah, thank you. Thank you, Keshav, for bringing out the nuances of the decommissioning policies and all that, but it needs further improvement so that your biggest operator is the ONGC. So you have to create a conducive atmosphere and you have to find out how they can start. Otherwise, it's not possible that a field of national importance and interest can be decommissioned. So I think hopefully the policymakers, they will think on it. So I am opening it up for the audience.
Yeah, you showed one onshore decommissioning project. In the flowchart, nowhere DGMS is there, because have you taken DGMS approval? And second question is, based on the Shell experience, have you brought on all other ministries and DGMS on board for any approvals or sensitized other ministries? Thank you.
For offshore, we have required OSD approval. For onshore facility, required DGMS approval.
Yeah, for onshore decommissioning, has DGMS approval has been taken?
Required, sir.
Was taken or not? That is first question. Second is whether all the ministries have been sensitized post the Shell experience for environment or reefing sites or the other things.
At
like
present, sir, there is no proper guideline for environmental impact assessment for decommissioning in India. Although there is an EIA guideline for development of field, but for decommissioning, there is no proper guideline for environmental assessment. And regarding the DGMS, this OSD and DGS approval is required after 2018 guideline. Before this is required ministry approval.
No, after your one onshore decommissioning you have approved. Whether DGMS approval was given, or has DGS brought all those agencies on board, because your flowchart didn't show the DGMS.
Okay, I have shown it for particularly offshore field, and for onshore field DGMS approval is required for that is the field in 2002 is DGMS.
Yeah, was it taken?
Yes, sir.
Thank you.
Yeah, in terms of environmental, we had quite a bit of struggle because it doesn't, as you rightly said, it doesn't come under the Environmental Impact Assessment Act. So we had made a special recommendation in the next notification to be brought in. And during the COVID, the next notification has come in. And still we see that decommissioning has not been brought within the ambit. I think globally, any decommissioning project goes through a very environmental ministry's close scrutiny. Here it is not being done. I think that is a correction which we need to look at.
Yes, sir. That is required.
Yeah. Any further questions to any of the other speakers? We can take one or two very quickly. Okay, I think give a big hand to Keshav and the entire session. Wonderful session. Very nascent stage and a very thought-provoking kind of thing. Some of us are here who are all struggling for the last so many years, and we are sorry to see this state of affairs. Till now, other ministries, Ministry of Environmental and Forest, MOEF, I know IOGP, IPCA, they are all part of the international forum where decommissioning is being discussed. Yeah. So we are just summing up. So our Director General of DGH has just joined. We are blessed with that. And there are very good presentations on the current decommissioning happening in Tapti field. Some onshore decommissioning happened long back with NICO, one of the facilities. The policies, the rules, regulations, and we feel, I think the House feels that a lot of improvement needs to be required to be done to give a proper space for a fast decommissioning, because the offshore platforms are getting old day by day, and Arun Mittal is sitting over here. He is giving consent to operate every time. It's so long. And internationally, the rules, I think the policymakers need to see that IOGP is there, IPCA is there. They have framed decommissioning rules where MOEF is connected, environmental, because environmental stewardship is a very important, I think, pillar of decommissioning. Once we are decommissioning, we cannot just scatter the things in the seabed, or we cannot pollute that. And another very important thing is that once the system is decommissioned, it's maybe one single platform with few pipelines, or maybe number of platforms, process platforms, machine and all that. What is the regulatory systems that once they will bring back to the on land, how they can be disposed of? We are not geared up. Our industry is also not geared up. There is no proper, I think, geared so that the platforms can be dismantled over there. So a lot of issues are there. I think this area needs further review by everybody, by the technical experts, by a task force can be prepared, and further improvement. That is the kind of thing where I think the bone of contention between the largest offshore operators, ONGC in India, and the other regulatory things is that our regulation says you have to decommission the field. So Bombay High field cannot be decommissioned because this is the national interest. So a part of the field, whether it can be done. So we need to look at that. So with that note, I think give a big hand to all the speakers, and it's a very interesting session, and thank you everybody. My job is, Arun Mittal, our...
Good afternoon, I am Arun Mittal, ED OSD. Two things are coming up. One, Petroleum and Natural Gas Safety in Offshore Rules 2008, which is mandatory for offshore, and decommissioning is done under that. That rule is under revision, and draft has been uploaded on OSD website. We are also circulating to all the member companies. You can give comments, and decommissioning we have brought within that. Even consent will be required for taking decommissioning. The rules we have modified, the annexure we have put for decommissioning. Environment impact is also required to be, and that also is coming up. Secondly, there was a working group constituted by Ministry of Petroleum and Natural Gas under Mr. M.K. Surana, ex-CMD, HPCL, a 22-member committee for looking into the entire gamut of safety systems in oil and gas sector, upstream, midstream, downstream, everything. That report has been approved. We have circulated today itself to all the companies. And that also, there is one of the recommendation that SRG guidelines that needs to be reviewed and revised. So we will be again making a committee for review and revision of SRG guidelines 2018. Okay, so we will take members from the committee, experienced persons will be there, and we will try to see how we can further improve upon, because we understand lot many structures will be required for decommissioning. So a lot of efforts are there from regulator as well. Thank you.
Thank you, Arun, for the great update. Things are going on and we are all hopeful, and so we should end this session with a positive note that things is going to happen very soon. Thank you very much.
Good afternoon, all of you. As we come to the end of this wonderful technical session, it is my privilege to deliver the vote of thanks on behalf of organizing committee. First of all, I would like to thank our session chair, Mr. Tapas Kumar Sengupta, ex-director officer ONGC, who honored this session with inspirational thoughts. I would like to thank all the presenters for their insightful presentation. I want to thank all the distinguished invitees present here accepting our invitation. I thank the members of the media for evincing interest in covering the event. Last but not the least, I want to thank you all my colleagues from DJS for cooperation in making the session successful. I want to request Tapas Kumar Sengupta sir to present a token of appreciation to our presenters. First, I want to invite Rajagopal Mahalingam sir from Shell. I want to invite Gurjat Singh, Oceaneering International Limited. Mr. Amit Jain from ONGC. I want to invite Pankaj Kumar Gupta sir, session coordinator, to present token of appreciation to the second chair, Tapas Kumar Gupta sir. Yes. Sorry. sorry. I want to invite Kesab Basa from DGS. Sorry. Now we have a group photo. Please come to the rise. Sorry.
Yeah, very good afternoon. It gives me an immense pleasure to see a large gathering at this stage, a group of senior technocrats, technical experts, business heads, and more so privileged to have Director General DGH in this session. So this session is unconventional sources of energy, potential and challenges. So recently the government has started giving much more focus to unconventional sources of energy, and why not? India has got around 9% of coal reserves of the world, vis-a-vis 0.3% of oil and gas only. So we have spent a lot of time, energy on oil and gas, and this is the time now to focus on unconventional. Unconventional holds a lot of opportunities. As I told, coal has got 9% of the total world reserves with India. India has got 93 TCF of prognostic CBM resource, 93 TCF, out of which 9 TCF has been made in place, reserves now, and only 0.2 TCF has been recovered. So a lot of potential holds with the non-conventional. Besides CBM, there are shale gas, hydrates, oil shale, so many opportunities. So India probably needs another internal transition before we go ahead for a long-term transition of 2070. So this is going to be, should be an interesting topic with speakers from different places across, for outside country also, within country, academia also is involved. So we have 4 presentations. And the session chair will be Mr. Dustin Fair from Reliance. So I invite Mr. Dustin Fife on this chair, guys, please. So he is heading Subsurface Reliance Industries Limited and has a vast experience. He started his career with production engineering, and he worked with all majors, oil majors of the world, Shell, Chevron, Aramco, BP, and he worked in India also for quite some time. And from production engineering, then he moved on to subsurface engineering, and he contributed a lot in that field also. So we are looking forward for a fruitful session ahead. Mr. Fai will take us through this session for the next 45 minutes. So all the best, and should I announce the name, sir?
Well, thank you for the kind introduction, and I really hope I can do as good a job as the previous chairs did. I'd like to thank the DGH for coordinating this meeting. These meetings are so critical for our industry. And I'd like to just say a few things myself about the unconventional industry. I'm from the USA, from the state of New Mexico. My family and I have a house in central New Mexico in a city called Albuquerque. 2-hour drive from my house, I can be in the San Juan Basin, which is the center of the coal bed methane industry, one significant unconventional type of resource. In the other direction, probably about 5 hours drive, is the Delaware Basin, which is one of the largest shale basins. So it's something very, very dear to my heart is the unconventional industry. And one of the reasons that is, and I've been looking back at the poster behind, where it talks about collaboration and innovation. And the thing that is so unique about the unconventional industry that's different from conventional oil and gas is the need to coordinate and collaborate between all different disciplines of engineering, of geosciences, of operations, in order to make these fields work. And a lot of times it is the brilliant thinking of just the working class people who make these projects successful. And I'll just compare back to the shale projects that we see so successful in the world right now. And most people here, I think, have tracked the unconventional shale industry probably somewhat over the last 20 years. Unconventional is unique because mostly we know where these resources are. In the western part of the US, in West Texas and New Mexico, we had drilled through these shales for the last 100 years. We knew the shale was there. We knew that the oil and gas were sourced from this rock, and that's where the hydrocarbons were generated and would eventually, through geologic time, accumulate for a conventional type of resources. Coal, we know about coal, and was mentioned, there's a huge coal resource here in India. There's many coal fields around the world that are gas bearing. So we know the resources there. What's unique is when people come up with truly unique and genuinely original ideas to develop these resources, and it turns into an industry. I'm very honored to be working in India right now. I'm very thankful for Reliance for giving me this job, this chance. It's a really unique experience for me, and I've been around the world for, I don't want to admit how long, but it's about 43 years this year I've been in the industry. Having had worked in Egypt, Saudi Arabia, South Africa, Australia, Alaska, the North Sea. So I've seen many, many places, and this is truly one of my most enjoyable places to work, not just because of the unique projects, but also the energy and unique intelligence of the engineers and geoscientists that I work with. So I'd just like to thank, the opportunity for being able to speak here today. So we have 4 presentations, and the last presentation is probably the most unique, and I'm guessing this is Ryan here. Okay, you're last. So the first 3 are about coal bed methane. This is something that I work quite closely with in Reliance. So one of my work associates here is presenting. But we'll go ahead and start out, and if I mispronounce someone's name, I apologize. Sometimes I struggle with names. The first presentation is Rajiv Upadhyay. Rajiv, is that right? He has a PhD in petroleum engineering, and he is an associate professor at ISM IIT. He has worked previously in Australia for Santos, Shell, and he worked for Reliance too. He is a specialist in reservoir modeling, conventional and unconventional. His presentation today is about CO2 sequestration in coal, which I'm quite interested to hear about this because this is a challenging field, and it is something that is even harder to quantify or harder to understand than a CBM development is how to store CO2 in CBM. So I'll be quite interested to hear what you have to say today. So I'll go ahead and hand it over to Rajiv. Thanks.
Thank you, Dustin. Thanks for my introduction. So, good afternoon all. My presentation is about CO2 sequestration potential in Jharia coal bed methane block. The study is very preliminary, and without any further delay, I am going to start my presentation. So, it is not okay. Okay, so when it comes to CO2 sequestration, we have 4 geological avenues where CO2 sequestration can be done: saline aquifer, hydrocarbon reservoir, CBM reservoir, and basaltic formation. And it is only the CBM reservoir where this CO2 sequestration can generate some revenue out of the investment that we are doing. In all other geological avenues, it is going to be investment only. So this actually enhances the significance of CO2 sequestration in CBM reservoirs. Now, a number of studies have been previously conducted in quantifying the CO2 sequestration potential of CBM blocks of India, but all of these studies are majorly actually related to based on empirical correlations, where CO2 sequestration potential is correlated with either coal rank or depth or temperature or vitrinite reflectance of coal. So what is the key message here is that there is no study here so far where flow dynamics of CBM reservoir has been taken into account in quantifying the CO2 sequestration potential, which is actually a very important aspect. Why it is important aspect? Because in a normal CBM reservoir where we are producing basically 2 phenomena that compete with each other. One is as we depressurize the coal, due to the overburden stress and due to the presence of cleat compressibility, the cleat aperture is going to decrease with pressure depletion and time, and leading to decrease in porosity and permeability of the reservoir. Whereas other phenomena, which is matrix shrinkage, because the gas was originally part of the matrix system, and as we depressurize the coal, the same gas dissolves, and that leads to the shrinkage of coal matrix, and this coal shrinkage effect increases the cleat aperture, and that's how the porosity and permeability of reservoir is going to increase. And it is the geomechanics that is going to decide which of these 2 competing phenomena is going to win. So anyway, what is going to happen anyway? Your porosity and permeability of reservoir is going to change with pressure depletion. Now, even if we go for a enhanced CBM project, there also we have one additional injection well, and here we have, unlike the case before, here we have 3 competing phenomena happening simultaneously: overburden stress, decreasing porosity permeability, matrix shrinkage effect, increasing porosity permeability, and due to matrix swelling, because we are injecting CO2 into the formation, porosity permeability is going to decrease. So basically it is not only geomechanics but also multi-component Jobson effects that are going to decide which of these 3 competing phenomena is going to win with time. And again, whatever is happening, your porosity and permeability of reservoir is going to change with pressure depletion, and that makes porosity and permeability dynamic in nature. So it is not only porosity subsurface parameters like porosity and permeability, but also the behavior of CO2 fluid as a fluid that basically going to drive the flow dynamics in the reservoir. So 2 charts you see here. One is your pressure versus temperature of CO2, other is your pressure versus viscosity. And what is typical about CO2 is that its critical temperature and critical pressure. So critical temperature of CO2 is about 30 degrees Celsius, critical pressure is about 72 atmosphere, and beyond any pressure above this or temperature above this, your CO2 is going to exist in the supercritical state. And if we see the normal depth range of our CBM reservoirs in India, like 450 meters to about 1100 meters, your CO2, what you are injecting is going to be either in the vapor state or supercritical state. Now supercritical state is typical because its density, you can see the plot, the density of supercritical phase is near to liquid density, but the viscosity of the phase is near to gas viscosity. So that makes the supercritical fluid different from normal fluids. And whether it exists in supercritical state or subcritical state, it's something which is going to drive the absorption capacity of coal with respect to CO2. The density means, you can see here the normal adsorption model. If it is in supercritical state, normal adsorption model will be different from what we have. Viscosity, it is going to drive the rate at which you are injecting the CO2 in the formation. So it is both subsurface parameter as well as behavior of CO2 fluid is that going to drive the flow dynamics in the CBM reservoir, and it is effectively going to decide the CO2 sequestration potential of CBM reservoir. So what are the key impact parameters? Of course, apart from normal subsurface parameters, porosity, permeability, geomechanics, what other things when we are starting CO2 sequestration, when breakthrough of CO2 is happening, and what are the operating conditions? Means the operating conditions are going to decide whether it is going to exist in subcritical state or supercritical state. And our strategy on breakthrough will decide if the project is going to be a CO2 sequestration project or enhanced CBM project, depending upon when we are stopping the production well or injection well, when the CO2 mole percent exceeds certain limit. Now Jharia CBM field is typical in nature because we already have 10% CO2 mole fraction in the production stream in Jharia CBM block, and that makes it a special case. And here the levelized cost of CO2 avoidance will be nil, making it most prospective for the implementation of CO2 sequestration. Now what we did, we implemented all this aspect in the form of model. We developed our mathematical model, incorporated all the subsurface aspects, also the CO2 reservoir fluid behavior in the model, and we tried to quantify the CBM CO2 sequestration potential. And what is the outcome? You can see here there are two plots. On the left hand side, your CO2 injection profile is there, and you can see how CO2 mole fraction is increasing in the production stream as we keep on injecting CO2. On the right hand side, you have CH4 production profile, and there are three cases here. Case 1 corresponds to the case where no CO2 sequestration is done. Case 2, when we keep on injecting CO2 in the formation. Case 3 is when we stop injection well, because as we are injecting, the CO2 mole fraction in production stream is also increasing. So we can basically decide beyond a certain cutoff limit, we can stop our injection well. And all these cases, so case 2 and case 3 you can see here, because case 1 is about no CO2 sequestration. So case 2, the total sequestration potential is 49.6 million meter cube per kilometer square. And case 3, where we are stopping our injection well, CO2 sequestration potential is 9.1 million meter cube per kilometer square. Again, other production strategy is that we can stop our production well also, because if the CO2 mole fraction is increasing in production well, then first strategy was stopping the injection well. Other strategy can be, what if we stop the production well and our coal reservoir will become a target for CO2 sequestration. So in this case, your case 2 and case 3, case 2 is when you keep on injecting CO2 in the formation. Case 3 is when you stop our production well, when CO2 mole fraction exceeds a certain limit, cutoff limit. And the result is, again, case 2 is similar to the case before, so it is 49.6 million meter cube per kilometer square. Case 3, you are having 24.4 million meter cube per kilometer square. So this is all based on preliminary study, and ONGC data may help fill the gap further. So what are the key conclusions? One is that preliminary mathematical model and desktop analysis suggests that there is encouraging potential for enhanced CH4 recovery in Jharia CBM block. Apart from subsurface properties and CO2 fluid behavior, what is important in CO2 deciding CO2 sequestration potential is that at what pressure CO2 is being injected, when it starts, when the injection starts, and then how to deal with the CO2 breakthrough when it produces from the production stream. And a pilot scale study is very much essential in Jharia CBM block, because there we are already having about 10% CO2 in production stream, which can be injected into the formation, and a pilot scale study can be done. So that's all from my side, and I'm open for questions if any.
Okay. Thank you, Rajiv. We have time for a couple questions, but I'll ask one first.
Yes.
Are you assuming this into a virgin type of CBM field or into a depleted field?
It is a virgin.
Okay.
Virgin, yes.
All right. Okay, thanks.
Not depleted.
Okay. Any other questions, please?
No, not as such a part of this study is not having economics, but of course, economics is the next step.
Okay, thank you, sir. Thank you.
Yeah.
Okay, no more questions. Well, let's
Okay.
give him a hand of applause.
Thank you.
The next presentation is from Jagadish Chand from Reliance. Jagadish is a work associate of mine that I spend quite a bit of my time giving a difficult time to. He is the head of the CBM subsurface for Reliance. He has worked in the KGD6 blocks in the MA field, and also he worked in PMT, Panamukatapti JV at some point. And prior to that, he had 18 years experience with ONGC in various basins. So, JC,
thanks,
go ahead.
Justin,
Thanks.
for the introduction, and thanks DGH for giving me an opportunity to present in this forum. So my presentation is all about coal-bed methane production enhancement. I'll give a Reliance operated field. I'll actually talk on that. And it is basically the integration of the current subsurface understanding with the latest technological developments. So can you go to which next? Right. Assembly is doing down. No, down actually. Arrow, yeah, right. So this will be the presentation sequence. Like I will touch upon slightly on oil and gas scenario, and typically I will be telling more about the challenges in the production enhancement and the production enhancement opportunities and summary and conclusions. So now, as of all of us, we are aware that there is a huge gap in the demand and supply as far as the oil and gas is concerned. And here comes the role of unconventional plays, particularly the CBM, the tight gas, the shale gas, all actually this has got a huge resource base, and it will have a significant potential, and it can reduce the gap between this demand and the supply. And as you know that India has the 5th largest proven coal reserves in the world, and it has significant CBM potential. So as Jains have also told that actually the current prognosticated CBM resource in our country is 93 TCF, and out of that only 10 TCF has been moved into proved in place, and out of 10 TCF only 2.5 or 3 TCF is in the reserves. So there is a huge opportunity to convert this prognosticated resource into JIP and then into reserves, not only bringing the more areas into ambit, but also from the existing fields we can improve the recovery factor from the existing fields. So now coming to the what is coal bed methane, actually as you know that coal bed methane is nothing but that is similar to natural gas, and predominantly it is methane, and here both the coal is acting as a both core source rock and the reservoir, and this methane is formed during the coalification process, and here what happens, the gas is generated and it is adsorbed to the coal matrix through the van der Waals forces. And here the water almost occupies the pore spaces and the cleats, which is known, mostly the fractures, which is known as the cleats. And as the depressurization, we go on depressurization, methane is dissolved, and with the reduction of the pressure, the gas is released and it is produced at the surface. Now this is that our area of interest. It is in the Sohagpur field. It is in Madhya Pradesh. It is in the South Rewa basin, and we have got a thick coal-bearing sequence, that is the Barakar. And this average depth of the reservoir is 400 to 1000 meter, and there are 5 major seams, and there are other minor seams also, but there are 5 major seams which we are targeting for production now here. So now coming to the key variables which influences on the CBM reservoir performance and the well deliverability. So basically the gas content, thickness and the depositional settings, they majorly contributes towards the resource. And it helps in maintaining the achieved gas rate and hence the long-term EUR. And whereas the gas saturation, permeability, the reservoir pressure and the cleat orientation, they majorly govern this basically towards the reserve. It impacts both the timing of the peak production and the peak production rate, and hence it impacts that short-term EUR. So now coming, sir, as actually that like every operator, we also started development of our field initially with vertical fracked wells, and we clubbed, since there was number of multiple coals, we clubbed these coals into different zones and we fracked it. But of late what we have seen that the actual production, which was what we envisaged, it was far from the expectations. So basically then we came to know what are the issues, what are the challenges in the vertical fracked wells. So I have categorized into 3 subheads: geology, reservoir and operations. Geology, the challenge was that we were not having any seismic data. So basically the coal continuity mapping was difficult. And also this actually the structural elements, particularly the faults, the channeling, they were very difficult to map all these things. Second challenge was that the low stress anisotropy between the coal and the overburden sandstones. The coal and the sand, they are having almost equal frac gradient. So whenever you are fracking the coal, basically instead of going into the horizontally into the coal, it moves vertically up into the sandstones. And if the sandstone is permeable, it will bring lot of water. So you get short fractures with limited reservoir contact. That was the problem actually what we have seen in our field. And third is that there is a thick intrusive body which is almost 150 meters thick. And this actually somewhere it is outcrop, somewhere it is in subcropping. So basically that there is a definitive dip is not there for this dolerite. So that is why what happens, sometimes it comes very near to the coal, and when it comes very near to the coal is devolatilized. So that is one problem, and this dolerite also is a source for the extraneous sources of water. Whenever there is a fracture which is connecting this coal from this dolerite, this dolerite is actually sourcing the water into the coal. So this is the challenge in the geology, and there is, yeah. Then there are some reservoir challenges, the ineffective frac job, due to vertical height growth and limited reservoir contact, which has led to the more water production and suboptimal gas production. Operations wise, we had problem of sanding, that is propent flow, then scaling and prolonged dewatering due to extraneous water sources. Now coming to that enhancement opportunities, we have now moved from the vertical frac wells to the horizontal wells now. So we have drilled many horizontal designs. One is the down dip design with a typical intersect well. Then we had up dip multilateral wells. Then single seam, single lateral, single seam, multilateral stacked wells also. So all these wells we have tested in different pilot, and what we have seen, this actually horizontal well, it helps in enhanced reservoir contact, and it manages the reservoir heterogeneity by connecting the more fractured system. And this advanced geosteering, it has helped drilling the laterals, long laterals, without exiting from the coal. And we have used only formation water without any mud or without any chemical, because that will damage the reservoir. And fourth is that we have done air-assisted underbalance drillings. Wherever there is total loss cases, we have gone with the air-assisted underbalance drilling. So this horizontal wells, they have the potential for multifold increase in the production rate as compared to the vertical wells. Now coming to the advancements, cleat orientations. Cleat orientations play a very important role in the horizontal wells. The laterals has to be placed in a proper orientation. So for this, actually we had done some mapping right on the outcrop in the mines and from the image logs also. And this orientation of these laterals should be perpendicular to the maximum horizontal stress. That is, it should be in the butt cleat direction, so that it can intersect a number of face cleat direction. So this was actually done in our most of the wells now. And next is downhole gauges, installation of downhole gauges. In all the horizontal wells, we are having now downhole gauges. So this makes our there is a reservoir surveillance and day-to-day operations, and hence less well intervention. And then for the reservoir simulation point of view also, now earlier actually we were actually morely actually doing with 2D CBM simulators and map based. Now we have moved into 3D CBM simulators, and basically we are more actually all this well planning, everything has been done in Petrel. So our forecasting is also improved as a result of this multi-well simulation. Now these are some of the advancements actually which we have done now recently in operations. Now instead of the conventional PCPs, we have now actually using the HRPCP, hydraulically regulated PCPs, which have the better volumetric efficiency, and actually it works better even if the actually gas through the pump is more. And then future applications, actually what we are planning, that we are going for a foam lift. Actually we have to reduce the pressure to minimum 5 psi or 0 psi. For this actually the foam lift and the wellhead compressor actually will be working on this. So ultimate aim is to lower the reservoir pressure to the minimum possible extent and maximum reservoir extraction in a sustainable manner, as most of the resources can be produced in lower pressures due to the inherent nature of the coal. So coming to the summary conclusion, sir, the Sohagpur experience shows that the production improvement is 4 to 5 times from the horizontal wells than the vertical wells. That's what we have seen in our wells now, in the new wells. So we are been able to reverse our declining trend by drilling these all horizontal wells. This is what. Thank you, sir.
Thank you, Jagdish. So open for any questions, please.
Hello. Hi, sir. Thank you for this insightful presentation, first of all. Actually, I have a little bit question. Indian coal doesn't come in a compact thickness or size. Everywhere it goes and branching parent and daughter and such. So how do you see implementation of horizontal draining in thin coals? Is there any threshold thickness where this technology can be implemented, or what are your take on this, sir?
So actually what our experience, whatever we are now in a horizontal campaign, so we have drilled with 2 meters of thickness on coal. So we could be able to drill more than 1,000 meters because we have got GABI tool with us, the Adbit gamma ray tool. It gives a very good distinction, gamma distinction between your overburden and the coal. So 2 meters we have done in our field. And I know Dustin actually what he was referring earlier, that in Australia they have done with 1 meter coal also. That's what I have heard of from him.
Just to add to that also, we were drilling down to 0.9 meters in Australia at 14 to 1,500 meter laterals and staying within the seam without any exits.
Yeah.
So it really does come down having the right people doing the right job, talented drilling engineers, geosteers. But the other challenge is CBM is a very low-cost operation, and so you can't go for, expensive rotary steerables or some of the resistivity contrast type tools. So it really does come down to having the right people on the job, and so that's what we learned in Australia. And so when I moved here from Australia, one of the recommendations I made to Reliance was to hire the drilling manager from Australia, which we did. And so he brought a lot of that experience here, and it's really benefited the CBM industry here in India having him here.
Sir, my one question is that how you know that there is a frac height is going like...
We have done some, tracer, NRT logs actually we have evaluated. When we were actually pumping this propant, that time we have added NRT, non-radioactive traces. And later on we logged the well and we saw the height growth in the log.
Okay, at the time of the fracturing.
Fracturing also we have used.
Okay, so in the case where we have fracked the wells, so is there any things we can do if we are not getting a good production from that wells? We can do some test. Is there any test to know that there is a height growth?
Now height growth means actually if you are getting a lot of water, basically if you are overburdened, if you have got permeable sands, then you will get a lot of water actually. From your model, or if you anticipated whatever, it will draw more water. And your reservoir pressure, you will not be able to, lower your reservoir pressure. So that's what the thing when you come to know that, yes, the frac has gone up,
And one more question, sir. What about the HRPCP? Is there any case of failure of HRPCP in your wells? Because
no, actually we are using HRPCP only for new horizontal wells. It's perfectly working fine. Even with gas through the pump, is whenever it is very high, the volumetric efficiency is very good for this pump.
Okay. Thank you, sir.
Yeah.
Thank you for the enlightening session, sir. A small question, if time permits. Sir, I want to know what is the MD and TVD of these particular wells which have been drilled till date?
Actually, if you see our block, towards the southern side of the block, it is shallower. And once you move, it is deeper. So roughly, I can say you that TVD is basically, it varies from 400 to 600 meters. This is the TVD of the main coal, not main coal, yeah. Major coal.
So while drilling such wells, attaining the horizontal section, like attaining such a high degree of this inclination in such a small depth, which is you are saying 400 meter, do you face some critical issues while drilling?
No, we have not faced. Actually, whatever, see, we have already drilled around 15-20 wells. And wherever we prognosed particularly that, that where will be the coal top, how I am going to land it, bearing 1-2 meters of, that plus minus 2 meters, it has gone up or down. Not much. Actually, we have not seen any variation from our prognosis.
Thank you, sir.
Thank you.
Thank you, Jagdish, and please give him some applause. Okay, our third presentation is from Troy Dasgupta. He is from SR Petroleum. Don't see him. Where is he? Oh, there you are. Sorry. Master's degree from IIT Mumbai. And you've worked for Reliance, Wipro Energy, and you're an expert in LWD, wireline logging, petrophysics, and unconventional reservoirs. Is that right? Okay, thank you very much. I'll hand it to you.
Hello everyone, my name is Troy Dasgupta. I am here to present in this topic of exploration of deeper coal bed reservoirs, and we are working on the optimization of hydrofracturing design for optimum production. So my agenda will be, I will be briefly talking about the background geology of the area, followed by the problem statement and the solutions that we are thinking of that. And right now you can see the brief solutions are the well spacing optimization and maximization of the reservoir contact area, followed by conclusion and the references. So our block is known as RGE CBM 2001/1. It was awarded to SR by Government of India in 2002. It is marked by the blue color and it is situated in the eastern part of India in West Bengal. We have drilled more than 400 wells and we have more than 40 core wells and more than 300 wells are producing in our block. Now coming to the brief stratigraphy of our area, the basement is metamorphic, which is followed by Talchi formation, and it is overlain by a thick shale, which is very much prospective in terms of shale gas. So it is known as barren measure. And it is overlain by Raniganj formation, which is our main target zone. It is more than 500 meters thick, and there are quite successions of coal seams. And it is overlain by a thick clay zone, which is the Panchayat formation, followed by Rajmahal trap. Coming to our concern zone, which is the Raniganj formation, it has got 6 coal seams named as RN6 to RN1, and RN1 is the bottommost. Now main thing is that as we go deeper, the gas content and the gas saturation increases. But we have very low permeability in these coal seams, and the main problem statement lies only there. As we can see, there are two pictures. In one of the picture, you can see it is the volume versus the pressure plot is there. Mainly in CBM reservoirs, what happened is that dewatering is the first stage that happens. So once the bottom hole pressure goes down and touches the curve, and we reach the critical desorption pressure, the gas comes out, which was absorbed on the matrix. Now it comes to the cleat. Now, main problem is that in these deeper coal seams, there is faster gas breakout, which tells us that there is potentiality of gas and good gas saturation is there. But the production fails because of the low permeability. What we are suggesting is the possible solution to increase the optimum production is that first, optimization of the well spacing. Second is the maximizing the reservoir contact area. In the next nearby graph, you can see it is the cumulative gas production versus permeability. Now, when the permeability is quite high in the right side, the frac length doesn't play a major role or doesn't impact in the gas production. But our permeability range is very low. It is less than 2 millidarcies. So once we increase the frac length, so the gas production increases. So this is one of the solutions. And we are focusing on maximizing the prop length. Another is the horizontal well or the multilateral wells in the seams so that our gas production can increase. Now, coming to the first solution is the well spacing optimization. So more the number of wells as their distance is reduced, there is interference that happens and pressure interference happens and the whole coal seam is drained out so that more of gas production can take place from the multi-wells. So in the right side graph, we can see our wells with the older wells which are marked by the green color and the newer wells which are in orange and the red color. So more multi-wells are introduced. We can see that the gas production has increased because of more drainage from the coal seams. We have acquired certain important petrophysical data that helps us to understand the physical properties of the coals. We have recorded the dipole sonic, which tells us about the anisotropy present in the system, which tells us about the cleats in the system, and the borehole image log also tells us that the natural fractures are present. But one of the important information that we got from this image log and from the dipole sonic is that as we go deeper into the deeper coal seams, the anisotropy decreases. That means the cleat structures gets fused, and that's why the permeability is also reducing. This is one of the indirect evidence of the permeability. And another important information that we got from this image log and the dipole sonic is the stress directions. So maximum horizontal stress we got from the natural fractures, and the borehole breakouts gave us the minimum horizontal stress. So these informations were used for the lateral well placement. So once we are defined about the enhancing the frac length, we got the Poisson's ratios of the coal as well, which helps us in designing the frac. Two direct evidences of the dynamic property are the IFT data and the defeat data. IFT data in this coal seams also gave us the indication that the permeabilities are quite low. It is coming in the near wellbore, it is around 2 millidarcies, and the far it is 0.82. And the defeat data also gave us a value of the closure pressure, which is quite high, and the minimum horizontal stress also we got. So coming back to the problem statement, so we got the three direct evidences. The anisotropy that gave us the indication of the permeability due to the decrease of the anisotropy as we went down, and the IFT and the defeat data gave us the direct evidence of the permeability. Now, since we are planning for the betterment of the frac design, these values, the geomechanical properties and this petrophysical data helped in designing the proper fracturing length. Possible solution for the frac design optimization, we have done some simulations with the sand yield and the sand size. These are the different results. We found that once we increased the sand yield, which is around 8,000, and we introduced the smaller sands, which is 40 by 70, the frac length is longer. So we can see that the frac conductivity is higher. So if we design the frac with finer sands, we can increase the reservoir contact. And also the lower viscosity of the propellant, viscosity gel also helped us. Now, dewatering rate optimization, there are two cases. If we fastly dewater the system, there are more chances of the coal fines to enter into the cleat. That will reduce the cleat size, and ultimately we cannot drain the area. So we cannot reduce more from the cleat system. So it has to be the slow dewatering so that the velocity of the propagation is very slow. We can see that from the two diagrams that if the first stage, which is the dewatering stage in CBM, is followed by the second stage, which is the gas and water interference. Once the gas comes into the system, the velocity slows down. And the third stage is the gas. It means that more gas is dissolved from the matrix. So primary focus will be always to extend the first phase so that more of the dewatering can be taken place at a slower rate so that there is more of production from the target seam. So this is how we have planned. The stage 1, we can see that there is the dewatering stage, and stage 2 is the desorption stage, where the first phase, which is the water, as well as the second phase, which the gas plus water both are existing in our system, but we have planned accordingly so that we can get more of gas. Coming to the conclusion, majority of the gas production in our wells are from the seams which are less than 1,000 meter depth. But the problem that we are encountering, the deeper seams have very good gas content and very good saturation. Only the problem is that very low permeability. So we are planning for the high frac length, which is very much needed, so that more of reservoir contact area we will get to enhance the production. And also optimum dewatering is required so that more of drainage radius we get and more of gas is drained from the majority of the coal seam. So these are the references which were used. Thank you.
Please. Well, I have a question.
Yes.
You're mentioning in your fracture design you're using polymers and gels. In the CBM industry since about the late 1990s, there have been quite a few papers written that gel absorbs onto coal and prevents desorption of gas. And because of the low temperatures of our CBM reservoirs, the organic material doesn't break down very quickly. And so this is one improvement that I've seen in my career in CBM developments, is going to strict water only fracturing and drilling. So have you guys considered not using polymers in your fracturing, going to straight water fracturing?
So, Karit, can you answer it?
Yeah, we were speaking earlier. Hi.
Sir, currently we are using linear gel which have the viscosity of around 25 cp to 40 cp, and we are moving to HVFR fluid, which is more cleaner as compared to linear gel, sir.
So because both in projects I've seen where we went away from polymer drilling and cross-link gel fracturing, we saw step changes, improvements in the well performance. Although it's harder to do both, it's really hard to place proppant in water fracturing. And then in drilling with straight water, there is hole cleaning and other problems too. But once that can be mastered in multiple projects, I've seen, like I said, step changes, orders of magnitude improvements in production. So just a comment.
Yeah.
Okay,
thanks.
Thank you.
Any other questions? Okay, well, thank you very much, Tori.
Yeah. Yes, that is why in one of the solution we have proposed the horizontal well as well. Like two things we have proposed, like optimization of the well spacing so that the maximum gas can be drained out from the coal seam. Second is the improvement of the frac length, and the third is that your placement of the horizontal wells. So that's why the image log and the dipole sonic were also acquired, so that we get the proper direction so to place the laterals. So we are in that like way only. So
well, and what is the lifespan of horizontal well?
Lifespan. So lifespan depends upon your drainage, right?
For for vertical well, it is around 20 to 22 years maximum. For horizontal, is there?
I think Jagdish sir can better answer that. Yeah.
Okay, sir. Okay.
It depends upon the drainage, right? Okay. Drainage and how you are draining that, and how is the connectivity. Like not only one lateral, if you are placing the multilaterals as well, so that the rate of desorption is a faster one, so that you can get more of gas from that.
But the tails in CBM well, the production tail is very long.
Very
so
long.
The life of the well is based on your economic cutoff. So it can go 20, 30, 40 years. So horizontal and vertical doesn't really make a difference on the life of the well.
Thank you.
And also just one last comment for you too. The permeabilities you're listing in the Bowen Basin in Australia where I worked, our permeabilities were 0.1 to 1 millidarcies where we were doing horizontal drilling very successfully. So I do agree that that's a great candidate,
yes.
your deeper coals for horizontal wells, if you can get your fracture orientation, your cleat orientation clear.
Yes.
Okay.
Yeah, hello,
Thank you.
hello ma'am. Just a small doubt I'm having. Can we do seismic acquisition program for carrying out this well designing, that we can further means modify our well campaign and also for means horizontal drilling or for the fracturing? So it is being very nascent research, and I don't think many of these uses has been implemented, seismic particularly for the CBM exploration and development.
Yes, I do agree with you. We do have some 2D seismic lines in our block. Right now we are not planning for the 3D one, but obviously you are right. But since we have many core wells in our block, so it is helping us to correlation as well. But absolutely you're right for that.
Thank you.
Thank you, Tori. Okay, our final presentation. Now, in the world of unconventionals, this is on the outside of these strange unconventionals. We hear a lot about shale oil. This is quite different. This is oil shale, and I'm sure that Ryan will explain what that difference is. This is Ryan Clerico from Enefit. How do you say that? OUTech?
Outatech.
Out here, he is a Master's of Science from University of Central Florida.
I'm an American.
So am I. Okay.
There's a long story behind that as well.
Right. Certified environmental professional and project management professional, as well as project manager, as well as an environmental specialist. And you'll be speaking on oil shale and copyrolysis. So please.
Yeah, thanks, Dustin, and I appreciate the introduction. As Dustin said, I'm with Outatech, CEO of Enefit Outatech Technology. My colleague Riho Kruv from Estonia is here as well. We are going to make a strong pivot away from coal bed methane, the last three that you've heard, and not the pivot that you think we are. Oil shale is even a little more different, and it's a common misconception that we hear. So let me start with introducing who is Enefit, and probably more specifically, why does a tiny country in Northern Europe have an interest in the Indian oil industry? So Enefit is or Esti Energia, as it is known locally, is the national energy company of the Republic of Estonia. Been around since 1939. It's the largest employer in the country, and works in the full value chain of the oil shale industry, from mining all the way through to power production, oil production, and then direct-to-consumer services as well. But we're going to focus on two particular items of Enefit's core competencies today, and that's oil shale, retort gas, which is a byproduct of the oil shale processing, and then copyrolysis, which is shredded tires and waste, plastic waste. And we'll get into a little more detail in a minute. But I'm going to dumb this down really, really far to start with. So what is oil shale? It's a rock. And this is a common misconception that we get, that it's something other than we hear tight oil and tight gas and shale shale oil plays. This is a different industry. It's a sedimentary rock, significant amount of kerogen, which is a solid hydrocarbon. You heat it in the absence of oxygen at the appropriate temperature, and it releases a vapor gas mixture, which is then simply condensed back down into liquid fuels. As I mentioned, it's not conventional crude. It's not oil and tar sands. There is some similarities between those deposits, but it's a different play, and it's different from shale gas and tight oil. So how does the industry work? Estonia has been doing this for about 100 years. You start with mining, conventional surface mining or underground mining. We have it at Outcrop in Estonia. The deepest seam is about 400 meters below the surface. Conventional room and pillar or long wall mining. The retort is Enefit's core competency and core of the technology. It's what produces the vapor gas mixture. And then the downstream processing, that vapor gas mixture is condensed back down into liquid fuels, and it can either be sent to an upgrader and a typical refinery or sold direct to market. In Estonia, we sell into the bunkering fuel market. There is a solid waste stream that goes back to the mine reclamation, and then there's a significant waste heat capture component that fires the process and continues the process. So a brief history. I won't go all through 100 years of Estonia's competency in oil shale. I'll start in about 1980. So the plant you see on the left-hand side there is the first generation. That's the Enefit 140. We have two of them. It was commissioned originally, as I said, in 1980. The 140 stands for 140 metric tons per hour. A metric ton of oil shale is about 1 cubic meter. Was nominally energy efficient. The emissions admittedly weren't great at the time. The second generation plant you see in the middle, that was commissioned in 2013. Capacity is about twice the size, so it eats 280 tons per hour of oil shale. The emissions profile got significantly better. The pressures of the European Union significantly required significant improvements there. And then the third generation you see on the right-hand side, that plant is under construction today. It's scheduled for cold commissioning starting in fourth quarter of this year, hot commissioning, and will be fully online in the first half of next year. In the energy efficiency, the emissions profile, all of the environmental standards have improved over the course of of this development of this technology. The next phase, and this is the two Enefit 280s you'll see here, are taking a further turn towards the circular economy. And this is where the copyrolysis comes into play. Pyrolysis is essentially destructive distillation, heating, breaking down the hydrocarbons, and then recondensing them. As we all know, waste plastics are a global issue. You have this issue here in India, we have this issue in Europe and Estonia, we have the issue in the United States. It's becoming more and more difficult to process these, to collect them. Particularly low-grade waste plastics are very challenging to deal with. One of the things we started this program back around 2014 of replacing parts of the oil shale with waste plastics and mixing them in with the feedstock. So as I said, we've been developing this close to a decade now. Lab and bench scale testing is complete. Industrial testing in the Enefit 280 plants is ongoing. We've been able to successfully replace anywhere from 10 to 90% at the small scale. About 30% seems to be the sweet spot. Once you drop below that, closing the heat balance becomes a little more challenging. The oil shale provides a significant amount of thermal energy to continue the process. Oil yields improves, the CO2 emissions go down with copyrolysis, and the oil quality improves significantly. So one of the other things that Enefit and Estonia is moving into is transitioning actually away from the pure liquid fuels industry and into petrochemical feedstocks. And I see a lot of opportunity there. It's a higher grade value product. This is still early in its development. We're still working strictly in the fuels realm, but this is moving quickly. So a lot of the similar content on here as the previous slide. I'll move past this quickly, but there's two things that I did want to highlight. Sulfur content in the oil goes down significantly as we add plastics in, and the light-in yields from this process, replacing oil shale with plastics also is increasing significantly. So what's next? In addition to waste plastics, we're starting work with end-of-life tires. Again, challenging to landfill. You can pyrolyze those, heat them in the absence of oxygen. The management is a little different with tires than it is with plastic, so it's still in a little earlier stage, but we see a lot of opportunity. So why is this relevant to the Indian oil industry? There is oil shale in India. Back around 2007, DGH put out a paper doing some preliminary characterization of the oil shale deposits, mostly in the northeast of the country. What Denefit's competency is not just the technology, that's the entity that I represent, but the entire value chain and building up an industry, how to do that industry responsibly, how to make it fit within regulations. Denefit's operations exist within the EU, very challenging, and all of those things, all the central items you see there going together to make a strong, technically viable, commercially viable, economically viable industry. So the adaptation process, we have facilities in Germany for testing oil shales all around the world. We've done this with US, Jordan, Israel, Turkey, Morocco. These have all been run through our facilities, and we're looking forward to engaging with the community here and the industry here to see how this can be an important part. And I'm not going to stand here and say, this is kind of the summary here. I'm not going to stand here and say that oil shale is the solution to India's energy gap over the next 50 years. What I will say is that I do believe it has an important role to play in the energy mix going forward, especially if you consider the recycling component, the waste management component, and mixing in natural resources that your country has, mixing in waste products that your country has, and contributing to reducing dependency on foreign oil. Not to get too geopolitical, but if you're familiar with where Estonia is located in Europe, it is the NATO border with Russia. So independent, energy independence is a strong, important role for Estonia. That's why they developed this industry, and we see this as an opportunity to bring this know-how to India to help this country over the next 50 and 100 years as you continue your growth. So I'll wrap up with that, and I'm happy to answer questions.
Okay, please open for questions.
So, do we have any assessment of the presence of oil shale in India?
We do. And the timing, I wonder if oh, that's already closed up. I was going to bump back to that slide. That assessment was done around 2007, mid-2000s. And if you remember the timing from my slide, that the first plant came online in 1980, the major upgrade came online in 2013. I think it's an opportune time for a reassessment of those resources to see, was the original evaluation correct, technically feasible and commercially feasible? The technology advanced significantly. We weren't even considering plastics at that time. And so I think it's a very opportune time to reassess what India has and what that industry might look like here.
Thank you.
Yeah, I think it's well timed for a snack and tea break. So
I have one question.
Of course, go ahead.
Does the pyrolysis actually enhance the shale oil product, or is it something that you use just for the recycle benefit? Or is it something that actually improves your liquids or chemical production?
Yeah, you do get some thermal cracking with the pyrolysis process, but really what pyrolysis is intended to do is, as I said, destructive distillation. It takes that solid form, breaks it down into a liquid, and then you can separate that liquid out into various heavy infractions, light infractions, and then the retort gas.
And so you mentioned that a lot of your pyrolysis feed has cardboard and other type of contaminants. There are a lot of recycling centers in the world that are separating plastics. Is that something that you could tap into so that your pyrolysis feed is cleaner and you don't have so many undesirables to manage?
Well, and that's actually one of the advantages of the way pyrolysis works with waste plastics is it doesn't require the sorting that some of these higher recycling facilities do. It can accept those. I mean, there's an energy content, there's a BTU content of cardboard and biosolids and things like that. And so it uses that energy content to continue the heat, to close the heat loop. So it doesn't require the high level sorting that other recycling facilities do.
Is there a role for pyrolysis without the shale oil?
We're working on it. It's closing that heat balance is where it gets. And one of the other challenges, I didn't mention this as I went through, but with plastics, if you replace 10%, I had said about a ton of oil shale is about a cubic meter. If you replace it on a mass for mass basis, a ton of oil shale and a ton of waste plastics volumetrically is very different. And so it becomes a material management challenge as you're working through that.
The unit cost of production with respect to the crude oil?
Yeah, we get the question a lot. And we tend to talk about, break-even oil price, and we don't give out a specific break-even oil price. But the way I can frame it for you, and every oil shale around the world is a little different, but the easy way to frame it is if you remember the oil price crash in 2015. It's people in the United States, conventional producers couldn't give away oil. It was very challenging for them. Our plants never shut down. They continued to produce all the way through that. Now, our margins were lower, I won't lie there, but that kind of gives you an idea about the operating cost of the industry. It's different. This is another way that it's different from a conventional oil and gas in that it's capital intensive. To build a plant like that, it requires more upfront, but the operating costs are manageable such that you don't just switch off a well when the oil price drops. You're amortizing that over the entire life of the project, and you continue to employ those people, you continue to operate, you continue to contribute to the community, which again is different than a conventional oil and gas play where if oil drops to $20 a barrel, you may switch off a bunch of wells and suddenly half of your community is out of jobs. So it's a different way of looking at an industry.
Actually, my query was connected to that only, but basically pyrolysis is a very high temperature kind of operation.
Mid-temperature, about 480
400 to 500 degrees, that's a conventional.
Yeah.
For that you need a lot of energy.
And that energy is contained in the oil shale.
And that's one part of the cost,
Yeah.
one part of the capex. You need big plant to generate that kind of energy to create 400 to 500 degrees centigrade temperature. In absence of oxygen, that reforming will take place other than the well operation. So cost is a very important, will play a very important role. That's my...
Very true. Absolutely.
Sir, hello sir. Yeah, this way. Just a small query. What are the strategies for this oil shale exploration? How do we proceed for the just drilling or any specific technologies?
So there's a lot of existing data that's out there from core drillings that have happened over the decades here. And I think it's, as I mentioned to Ma'am earlier, it's a good time to reevaluate the core that has been drilled already and to look at those seams and see where, if an infill drilling program needs to be done. When we characterize oil shale deposits, it's done more as a mining operation than as a conventional oil and gas operation. So you're characterizing a certain amount of mineable tons within an area. And that would be the next step is for, and we've talked with some with DGH already about what are the next steps to more fully characterize the resource here and update what was done back in 2007.
Thank you.
We don't do that technology. Shell and Chevron have looked at it. The question for the audience was about, can it be done in place underground? There are in situ technologies. They're not, the industry has not been proven yet. They found some successes and some challenges with it. And admittedly, I'm not an expert in the in situ
so
process.
It's more similar to mining then, yeah? You'll have to mine it.
The depth of source rock, so at some places it's an outcrop. So it's at the surface. The The deepest seams in Estonia that we do conventional mining on are about 400 meters below the surface. Oil shales can go 1,000 meters below the surface, obviously not mineable at that depth. But that's part of the economic analysis is the mining component together with the oil processing. So. I will be around the rest of the day today and tomorrow, so I'm happy to answer questions. This is obviously a unique and interesting resource that not a lot of people know about, and my colleague Riho will be around as well. So.
Thank you, Ryan. Okay, so that wraps up the unconventional session. I don't really have anything else to add other than thank you to the presenters and the unique subjects that were given today. I hope people benefited from these discussions. So.
So thank you very much, sir, for this very wonderful session. So I'll invite individual speakers to collect one memento, please, from our side. I'll call Mr. Rajiv Upadhyay to come out to the stage, please. And I'll request Dustin Five, sir, to hand over this. For sure. Mr. Jagdish Chand, please. Tridas Gupta, please. And finally, oil shale man of India, Michael.
I legally can't take it back.
I'll request, one for our esteemed session chair. Yeah. From my side.
Thank you so much. Thank you.
Next session, please.
May I request everyone to remain here because another session is going to start soon. I don't know.
It's after session team. Okay, fine. Good afternoon. May I request all of you to remain seated because I think the tea will be served after this session. So let's have a little bit of more patience.
So please take your seats. So, very good afternoon. Now we are going to start a session which is very, very important and in the frontier areas of exploration and production for oil and gas. So, this session is about energizing role of artificial intelligence and machine learning in E&P. So, as you have heard in the start of this Urja Varta in the beginning when the Honorable Minister was addressing us, and then there was the session in which the industry leaders were talking about the future landscape of industry, E&P industry. Everyone was talking about the data, and as we all know that over the last 100 years of oil and gas exploration, little more than the 100 years of exploration in the history. This particular industry is quite rich in the historical data, and as we are venturing into new technologies, the data sizes are going to be more voluminous and more frequent. So, in all these plethora of various data vintages and all this, the online streaming of data as well of E&P industry, what remains to be done is to analyze them in the shortest possible time and to recognize what is hidden inside the data, the patterns and anomalies which can lead us to know the future exploration success and future exploration discoveries. So, in all these analysis, this particular technology which is artificial and in machine learning has taken a very revolutionizing kind of a step, in the sense that as it is happening in all other sectors of economy world over, AI and ML has taken over oil and gas industry also in a big way. It is revolutionizing the industry in terms of efficiency of how quickly we analyze data and get the results, and in also kind of giving us new insights which were not available earlier. So, in this current session, we are going to have 4 presentations, and they will be in different aspects of the industry, the E&P aspects of how we are going to deal with the exploration and deal with the production. These presentations will be made, and then that will also set the tone for the future research areas in AI and ML as long as E&P industry is, as far as E&P industry is concerned. So, may I have the privilege to invite Mr. Chandrasekharan for chairing the session. And as he takes his seat, I'll speak about a brief biodata for him. Please, sir, take your seat. So, our session chair has one of the illustrious career in E&P industry, which is spanning more than nearly 4 decades, and he has the distinction of working in both the national oil companies of India, ONGC as well as Oil India. And in his last assignment, he was holding the post of director, and later on also he took over as the chief technology officer in the same company. And currently he is also working as the director in D&M India Private Limited. So, prior to Director E&D Oil India, he worked in ONGC in various capacities, the last one being the basin manager of Krishna Godavari Basin in ONGC, which is one of the most challenging basins of India, and having started operation as his career as an operation geologist. So, he moved through different areas of activities and moved up also, finally taking a leadership role in ONGC also, and later on in Oil India. And he has the vast experience in all spectrum of E&P. And he has been instrumental in Oil India in achieving quantum jump in Oil India's exploration acreage portfolio and invigorating EOR process for production enhancement and what he introduced as the concept of E2, exploration, and EUR as the mantra. So now he'll be chairing the session for the current, he'll be chairing the current session with the 4 presentations which are lined up. And these 4 presentations are by 4 authors who belong to the academia as well as the operating oil and companies, starting from Mr. Nakul Verma, Umang Nagpal, Arun Babu Nalmara, and Dr. Bappa Mukherjee. So I leave it to session chair to speak briefly about them as they come over to present their papers. And now, sir, I hand over this proceedings for you.
Thank you.
Mr. Chandrasekharan, please.
Thank you so much. I think all these people are being punished. They are not able to go out for a cup of tea. I think, anyway. So thank DGH for giving me this opportunity, because and it's already over an hour late. So what I'll do is I'll keep my thing short, and maybe in between the presentations we can have a very brief discussion. But I think all of you who have been present in the panel session, plenary session this morning, I think a lot of things were talked about. I think Honorable Minister also told it's not laying blame, right? And he conveyed a lot of things in that one particular sentence. Like today, if you, I think there is more of GNG guys here inside the room, so I can take privilege of making a few statements, right? So today what's happening is the fields are old. We are unable to increase production substantially. Though we are able to arrest the decline. I mean, you ask any reservoir engineer, you ask any geologist, geophysicist, they will be able to tell you, they'll tell you their sob stories. But still, AIML has taken a space now. Many people look upon AIML as though it's a panacea. And Mr. Saloma was narrating a story of 80%, like 80%, he's confident about 80%, so are you able to bet your life on? So exploration is also something similar, like the risk of a dry well, haunts a geologist or haunts a geophysicist or an explorationist. And it's now not limited only to the exploration, it transcends to even the development and the production stage. So it's here that the AIML techniques and these advancements in the computing thing, they have given a lot of hope for most of us. But is this the panacea? Like, is this the cure for all, or is it going to be like? See, machine learning, the fundamental thing which dictates machine learning is you should have learning sets, you should have use cases, you should have sets. Data sets for learning, and then so you can go on iterating the whole thing. I mean, I'm not saying that it cannot be applied to exploration, but it can be, because exploration is nothing but pattern recognition, and machine learning is nothing but, I can say broadly, it's also a pattern recognition, and then applying the same set of patterns and then identifying the similar locales for hydrocarbon exploration. But when it comes to the production and the development, there is a huge scope. I am personally involved in many projects, so I can tell you that there are a lot of things happening around the world, and a lot of things are happening here in India as well. But one thing is, when I talk to youngsters, especially talk to youngsters, this I think I see a lot of people here very young. Many people have stopped even writing a mail today without going through ChatGPT, right? So it gives a sort of a that whether I should simply go by certain algorithms developed by certain people, or you should be the developer, and you should. So it's somebody told even now when he talks about the shale oil as or things like that as an artistic science, like exploration and development production is also an artistic science. So there is also a very famous statement which says that technology will help you, but it will not close contours, right? So you need to, as a geologist, the fundamental thing is the petroleum geology, understanding of the basin, understanding of the play systems, understanding of petroleum systems, that which. So with this, I'll stop here. But I think I should congratulate and I should compliment DGH. This particular, the selection of the presentations also. One, I'm seeing a complete production technology. One is in petrophysics, and one is in size phases. And I think another is in one is size phases, one is reservoir characterization, and one is a technology, like it's complete production technology, and another is a petrophysics. So it's a beautiful combination of the exploration and right going up to the use of AIML in the production side and talking about the facilities. So with this, what I'll do is I'll welcome. I think the first is Mr. Nakul from SLB. Yeah. So Nakul is a senior production engineer at SLB. He has more than 10 years of experience in the oil and gas industry. He possesses extensive domain knowledge and technical expertise in the upstream sector. He has been author of many international and national technical papers. I think I've heard him in our conference. So his passion to explore the depths of complexity and challenges to work provide solutions. Yeah, great. Please, Nakul. Go ahead.
Thank you very much
for
your
kind
kind words. Am I audible clearly? Yeah, okay. Thank you. So, thank you very much for giving us the opportunity to present firstly on the digitalization and artificial intelligence state of our global industry and in India. As we all know, India is, I would like to start with my session, but first I would like to show up some of the facts related to digitalization and artificial intelligence. India is right now acting as a leader in digitalization. We all know UPI payment systems app. So we are trying to bridge the gap in oil and gas industry lacking in digitalization and artificial intelligence. So this whole scenario and the requirement of digitalization and artificial intelligence is absolutely necessary. Why? Because we want to accelerate our time so that we can get more value. We want to achieve much better results in very short amount of time. So, for example, a few facts I would like to give. There are 127 devices globally per second which are being connected to internet for the first time. So it is pacing at a very faster growth. There are 37% of organizations which use AI in their workplaces. And believe me, oil and gas industry is lacking a lot. And this data is from the various sources. This is 2019 source from Gartner. And now the third fact, there are 15 to 20% average revenue growth and cost savings in various global companies that adopt digital transformation. So you can believe the size of market and the production enhancement opportunities available in digitalization aspects and artificial intelligence. With that note, I would like to start my presentation, which is related to production enhancement, especially in brown field, using digitalization and artificial intelligence related workflows. This is a case study. So I would like to give an evolution related to the digitalization industry. We used to have our simple workstations, desktops, in which we used to type Fortran-based computer program, if you all remember, small mathematical programs. And now we can easily get codes from internet. Earlier we had manual monitoring, now we have SCADA systems. Earlier we used to have manual digital maps, and now we are using GPS technology. So in this way, we are progressing very fast. Believe me, in the last 15-20 years, the digitalization landscape has completely changed. You must all be agreeing with me. In the last 15-20 years, now we can have much better control in our life related to our activities or in the performance of industries. So coming to the topic where, why is digitalization necessary? Why it is necessary in oil and gas industry for E&P companies? We have so many production challenges, especially when the field is getting old. That is the brown field. More is the maintenance requirement, more are the integrity related problems, more are the flow assurance related problems. there are numerous problems in brown fields and in unconventional fields. We all know unconventional gives us difficult oil and more expensive oil. Apart from that, it gives us more difficulty to monitor and do surveillance, so that we continue to enhance our production and move on path of more controlled way of production of oil and gas globally. I'm not talking about India, globally. So we have so many inefficiencies in our production operations, some of which we can know. We have known questions, we have unknown questions. We don't know what is the question, what are the problems, and some of them are, we know that these are the problems. How do I solve this? We don't know much, but what are the problems other than what we know is completely different thing. So it is a step-by-step process. So why digitalization? You get to know the questions we need to ask. That is one of the other important steps. Some of us, we don't know what are the questions which are still unidentified. So coming to the things related to inefficiencies, which are interdependencies. So there are numerous interdependent parameters, behavior of the subsurface, surface, network, and a lot of things. We don't know, we cannot map different things at different aspects if we don't have a compiled way of macro level of digitalization workflow or process system. So this production challenges, and along with the surface management, is a very difficult thing for us to manage. Now, how do the digitalization saves our problem? How do artificial intelligence save our problem? So you can see T1, T2, T3, these are the times. This is the production rate graph. After some time, the production rate drops. Now it is flat. We get to know at the point T1, which is the time to detect the event. The T2 is the time to analyze and diagnose that event. And T3 is the time where we take actions. Now what digitalizations do is, it reduces that T1 time. It drags it down to the left and get us information related to detecting it faster. Now, if we are able to detect it faster, we can analyze it better, and we can take actions on the same. So this is the early production optimization sustenance extra advantage of digitalization thing, which we try to achieve as an industry personnel. So how do we do it? Via digital intelligence and automation, from edge to enterprise. We have various technologies available now, such as edge devices, IoT devices, real-time sensors, which can give us data, and we can work on that data, optimize that data for better control, implement physics-based models, implement a lot of workflows related to data-driven decisions, and digitally manage our field, monitor our field. So we need to connect the data to give us various outcomes which are our targets. What are those? We need to boost production. We need to reduce our cost per barrel. We need to reduce our CO2 emission. How do we do it? We can only do it by increasing our efficiency. So if we are able to increase the efficiency, we are able to reduce our CO2 emission automatically. I will give you an example. Suppose in an offshore field, by implementing digitalization projects, if we are able to reduce 20 chopper trips by digitalization activities, suppose for well testing in unmanned platform, we can reduce more than 15 tons of CO2 emissions. So this is just a fact, a data given by Deloitte. So what I would like to say is, we have so many values and so much untapped potential in production solutions, digital production solution and artificial intelligence in oil and gas industry, including safer operations, reduce emissions, as I said. So the solution is much better hardwares, edge computing, that is much better algorithms, much better control. It is something like we are driving a car and we are sitting on driver's seat. We are not sitting on the back seat. So it is something like we have more control and more certainty of our field and we can detect and work on production restoration and enhancement problems. So as I said about the workflows, we have designed numerous workflows related to data-driven monitoring, asset monitoring, well surveillance workflows, network-related monitoring workflows. So all these kind of workflows are part of steady state as well as transient state models. So we have worked on transient state models as well. We all know that Schlumberger has provided numerous solutions related to transient behavior problems in industry globally, and we continue to remain a domain champion expertise along with the machine learning and artificial intelligence support. So we have three pillars, major pillars for digital production solutions: intelligent operations, production assurance, and asset performance. So all the industry problems are majorly related to these three pillars, and along with cloud deployment with our partner Cognite. So this is the heart of the architecture for intelligent operations, 4-step solutions, and can be further break down. So all this can be applied to well network, pipeline network, process platforms, process stations, everything, everywhere. So in this way, we have more than 29,000 assets digitally enabled with a lot of global, more than 30 global E&P partners, and digitalization is no way, digitalization has no stoppage. It will continue to innovate, it will continue to improve. Thank you very much for your time and patiently listening. Any questions?
Great. Thank you for a wonderful presentation. I'll just ask a small.
Yes,
so,
please, sir.
No, it's not a question, but I just wanted to know, because I thought I'll reserve that after Arun presents. But the dream of any oil company is to have a complete digital oil field, right?
Yes, sir.
It doesn't. I mean, I'm not making any political statement, but it becomes very difficult for them to manage it, because you ask the teams which build the static model, dynamic model, and then by the time the dynamic model gets made, the dynamics of the field, it gets changed. So there is a lot of lag time between actual thing and then. So how many of these companies have a complete subsurface to surface integrated digital field model? Is there any? There are some, I'm aware, but how do they manage it?
I would like to answer that. It is actually related to this workflows, automated workflows. So, sir, if dynamics keep on changing, but we have an establishment of automatic workflows which can detect and change the parameters of well dynamics immediately within 15 minutes or 30 minutes of the test data or virtual metering. That I mean to say that workflows are supposed to work on these kind of problems. So it captures the dynamics change with the help of the real-time parameters available at surface. For example, I would like to give you an example. So there is an oil well, suppose. So there is a production drop. We have made the dynamic model, and now after a few days, the production drops. There is some problem with the well. But we have the real-time data available with us. For example, in the gas lift injection well, we have gas injection rate, surface injection rate. We have gas surface injection pressure, FTH, fluid head pressures, and many other parameters available. So the function of the workflow is to use the physics-based model, which is the softwares, which is the backbone, and use the real-time data to collaborate and give you real-time dynamics of the well.
Thank you.
Something like that, sir. So it is incomplete to do a digitalization without algorithms and workflows in place.
Thank you. Thank you. Any more?
Any questions? Anyone? I know that we are all tired and we
I think
have our
the
tea. I'm
people
so sorry
in the back
for that.
have had a cup of tea, so they can.
Yes, yes.
Thank you. I think if there are no questions, we can.
Yeah. Thank you very much
Thank you.
to DGH and Urja Varta team. Thank you.
Thank you. Thank you. So I think we'll now invite Mr. Nagpal. Yeah, hi. So he has completed his MSc Tech in Applied Geophysics from IIT ISM, and then he is now working with ONGC. He is now working in the processing division of SPIC. I'm very happy to see that, the geophysicist who was just joined last year is able to talk about all these things now. And please go ahead and congratulations, please.
Thank you, sir, for the introduction. Hi, everyone. So today on this session of energizing role of artificial intelligence and machine learning in ENP, I, Umang Nagpal from ONGC, along with my co-author Ayush Kumar from IUCL, would want to present a study on optimizing seismic features analysis using machine learning. So what I believe is the data is increasing in geoscience domain, and machine learning methods, particularly unsupervised learning, have become very crucial because processes like seismic interpretation, now that is a very vital part of ENP, but at the same time it's very time consuming and laborious. I think most of you would agree. But using these methods like unsupervised learning, what we want to achieve is, like for example, using GTM, generative topographic mapping, SOM and K-means, we want to optimize and automate the seismic features analysis so that it could be more time efficient and we can eliminate human intervention. So what exactly is supervised and unsupervised? So in supervised learning, I just tell the machine that, hey, I have some output, here I have some input data and this is my output labels. So I'm telling machine how the data looks like. Okay, the machine is only required to classify the data. Simple cat and dog problem. But the real challenge is unsupervised learning. What if I don't know anything about the data? Anything. I have no clue about the data. I tell the machine, it's your responsibility to take the data, do whatever you want, find a story and frame a similarity and patterns between them. That is when the clustering comes into the picture. So I'll give a small example. Let's say I have n seismic attributes, fine. And what I do is I put them in a black box, which is my unsupervised learning model. Now what output I'm getting is, I'm getting a cluster associated with every particular attribute. For example, if I talk about, let's say, a set of attributes in ID number 1, it is associated with cluster 3. So there could be another seismic attribute put in the same cluster. Why? Because machine thinks that those kind of seismic attributes are somewhere similar to each other and they should be put somewhere together to form a geological meaning to it. And this is a rough iteration of clustering going on. So we'll come to a very simple and conservative clustering algorithm. K means number of cluster, means centroid. So how does it work? So in a blank lattice, I just initialize the raw data and then I put 3 points. I have chosen red, blue and green over here. Now these 3 points are my prospective potential centroids. Now after I've chosen those centroids, what I'll do is I'll look for the neighborhood points which are closer to each other. How I'm looking for similarity is using the Euclidean distance. So after I have assigned those observations to a particular cluster, the centroid would change because the mean of that cluster has changed, right? So I update the centroid. Now this clustering will go on until and unless, we find a point where the centroid is not moving. So we say that the entire clustering has converged. But this has a major drawback, that this is hard clustering. So when the data are overlapping, it won't work very efficiently and it doesn't give good results in case of outliner. And outliner can make K-means go crazy. So we have another option, that's SOM, which is based on soft clustering. It's a neural network backed algorithm. So on this map, you'll see it is basically a SOM map. That's a 2D lattice. On those lattice, I have processing units, what we normally call as neurons. So what happens is, if I give an input vector and every input vector, let's say, has weights associated with it, now that particular weight would look for the closest neuron or processing unit in the 2D lattice. Now once you find that particular neuron, you call it a best matching unit, and then that particular neuron changes its weights accordingly that it behaves like cluster. So the neurons or the processing units in that lattice are trying to mimic how the cluster should be. So a small example I'll just quickly go through. I have 2 processing units, blue and green, and 2 clusters. So I select a random input. Now the green neuron is near to the first cluster, so that's my winner neuron, and it's selected and the weights are updated. just gives a little example, and it goes on for other input also. So now blue is selected because blue is closer to that bottommost cluster. Now it would go on until and unless the neuron has completely mimicked the input cluster. So the first cluster becomes green, similar to the green neuron, and second would become blue. So the study area we have taken is open dataset, F3 Netherlands offshore block, and Panospect data from Nova Scotia, Canada. Inline, X-line have been mentioned in the slide along with 2-bit travel time. So we start with extracting inline, X-line and time slices using a Python code. We compute seismic attributes, we do some noise attenuation, some pre-processing is done, and then we perform principal component analysis. We get the output and compare SOM, GTM and K-means results. On the left we have inline section of F3, on the right we have Panospect time slice. So moving forward, so the normal seismic trace we have is eventually the real part of a complex seismic trace, and it permits the unique separation of envelope amplitude and phase information, which helps us to calculate instantaneous frequency, which is a seismic attribute. So these attributes specify geological, physical and reservoir property and help us reveal those relationships and patterns which can go unnoticed from a human point of view. So in this paper we used around 15 seismic attributes. On the left we have computed them using a code. On the right you would see the filtered version of it. So for filtering we have used a Kohara filter that basically redefines the edges and removes the noise and outliners from the data. So the most important part of data pre-processing is removing the redundant attributes. So we are extracting seismic attributes from complex trace. So there is a high provision that those would be highly correlating with each other. So using the heat map, we remove those attributes which are highly correlating and those are redundant. And we put them into a PCA model and we choose 4 PCA vectors having total information of more than 80%. So this is our output for SOM. So all the 4 PCA vectors we got, we put them into our SOM model. Now the model looks for similar patterns and clusters them together. And we also created a RGB neuron mesh. So in that particular, every color code, every hex code would have a weight associated with a particular processing unit. So now you can see that the 16 cluster map would have 16 species, but that would not be geologically true. There not be geologically 16 species present. But using less clusters can also be a problem. Why? If you're looking at a 256 cluster, you would see the sigmoidal bedding is present and it is noticeable and evident, but that's not noticeable in 16 cluster. But at the same time, using high number of cluster is causing problem because it is overfitting and every small cluster is thought by the machine to be seismic species. So over here a lot of QC has to be done, that is it really true in nature or not. GTM gives a similar kind of results, but as you will see, it is the seismic is more chaotic here and the resolution is a little bit increased as compared to SOM. Now coming to K-means. Now one important factor about K-means is if you're using less number of clusters, the data, the output on the map is not coming very good. Hence, on increasing the number of clusters, we are achieving decent results in par with SOM and GTM. Now we have tried to compare our results with a supervised learning algorithm in a paper by Sivastri D in 2018 AEPG. So he used a deep learning method using CNN to segment these seismic species. So our SOM model on the left side is also able to identify 7 species. We validate our results with an unsupervised learning used by Napoli 2020 paper. So the author tried to segment to identify 8 species, and our SOM model also identifies 8 species better than what the author did, and the gas chimney species blue is also very evident. So at the last, I'll say that this is the output of Panospect also, but what we want to achieve is we want in future a case where if I'm looking only for channels or if I'm looking only for, let's say, faults, only those clusters should be present instead of other clusters which is coming and distorting the entire picture. So that is what we are planning. So if you are planning to look for channels, only channels should be present, only species which are representing channel in the particular cluster should be present. Now, since we do not have any ground truth available, this is unsupervised learning, so we need a matrix that could basically control the number of clusters we are using. So this is a cluster validity index that we used. So these three are coefficients and index that normally is used as QC to select the number of clusters. In the nutshell, I'll say that the unsupervised methods like SOM, K-means and GTM are very, very sensitive to the attributes you are choosing. So the selection of attributes in training basically depends on what is your specific objective at that point of time. So these unsupervised clustering algorithms hold great potential in understanding the geology where there is no data available. But if we have well data, this combined together can hopefully give good results. Thank you. I'm open for questions.
Good, thank you. Yeah, please. So,
really very detailed study and comparison that you have made. What I would suggest is that since this is a data which is related to North Sea,
yes,
it's a good opportunity that you try a data from one of the Indian basins which has good data control. First to test the method that you have applied in that data and how far you are able to get the success in terms of the facies identification. And you can also, I think, try other deep learning methods, like CNN and others, which gives you more better control in hyperparameter optimization. And see if this unsupervised versus that supervised gives you a better chance of understanding. But as far as I understand, if you are going for a kind of a quick scanning of a totally a new data, a large data set, and where not much information is available, it can give you a very quick result.
Yes, that's
so thank you.
Thank you, sir.
Very good analysis.
Hi. Yes. Thank you, sir.
And one suggestion just I am giving, as you are working in a category 1 basin, lot of data is there. So take any of the data from that field and do this type of analysis. Okay.
Yes.
This was done, I think, from the foreign basin. A lot of uncertainties there are in the carbonates there. So take any of the data there and do this analysis and come forward.
Okay. Thank you, sir.
My name is Rajiv Verma. In fact, I was there in Mumbai offshore block.
Okay.
Just 1 month back I came here. Okay.
Okay. Okay, sir.
Please.
Definitely. Thank you.
Thank you. Can I?
Yes, definitely.
Can you please go back to what is the number of total facies you have brought out?
So I don't.
8, is it?
Yeah. I mean, the last result I am showing is 8.
So you have divided the whole thing into 8 facies.
Yes, yes, that's what I'm.
So do you think that it is practical to do it in a? Because see, it's an excellent thing. I congratulate, I appreciate whatever has been done. It's wonderful. But my point is there are 2 things which I wanted to know. One is the difference in the computing from the normal whatever we do and whatever you have done. Have you sort of seen what is the difference? What is the difference? Because see, all these sort of advanced thing requires a lot of computing power also.
Yes.
But in my opinion, it may not be so much in this particular case because it's. I mean, I'm sorry. Correct me wherever I'm wrong. Please don't. There's a technical session, so don't worry about anything. Please feel free to what I think is it's not. It wouldn't have taken because it's the K clusters and things like that, or big data analytics algorithm and those sort of flows. Okay. So my only point is you can divide it into n number of classes. That's there, but ultimately it's the if I may put it, this is only for your when you go back and then have a look at what you have done. So it's like complicating and then uncomplicating, right? So I mean, if you have anything to say, you can say, because it's very practically difficult to divide in a modeling time when you do a static model or whatever modeling you do. So we try to increase the number of classes, but ultimately we come down to a manageable thing. Okay. So that's it. If you have anything to say, please say. Otherwise, wonderful. Thank you.
So thank you for your suggestion, sir. So I'll just pick on a few things what I understood. So first thing you said, what normally is done in industry. No, sir. Unfortunately, I've not been that exposed. I've just joined. So what I've tried my best to do is, since there are literature available of this particular result, let's say done by a particular author. So my best validation could be to check if my model or my parameters are fine to use it and tune my data and do it accordingly. So that's what I try to do. But yes, what normally happens in these unsupervised methods is, I agree it's quick, no issues, but sometimes the convergence of it may be troublesome. In K-means, the biggest problem is you won't be able to look into the local minima. It gets stuck there sometimes. So, and SOM, for example, if I'm talking about, let's say 16 by 16, it gives good result. But sometimes if you go for high clusters, it will continue to run because we are using 500 epochs for that particular iteration. 500 epochs for one cluster would take 10 minutes at least for the minimum starting cluster. So the entire thing with unsupervised is you have little control. So to tell that this is the cluster I want and this would only give good result, if we could use some physics into it, geology into it, then I think
that's right. That's what both of them were saying. So ultimately, like there is going to be a paper who is going to talk about supervised learning. Okay, so I think this is an interesting topic. We can go on talking about it. But I think wonderful. Congratulations. Keep up the good work. But since you have just joined the industry, go back to the basics. Back to basics always, so that the geology and the basic geophysics should guide your thing. Congratulations once again. Thank you. Wonderful presentation. Yeah, I think now we will call upon Arun. Mr. Arun Babu Nalmara. He has completed his MTech from IIT Bombay, and then he started his career as a geophysicist in Kane, and then he was in Jubilant, and he is now running his own company as well. And now he is also, I think you are advising Ceylon, right?
Yes.
And he is in an advisory role in Ceylon exploration. And he is a very passionate guy. And do you think that you can spend half a minute whether LLB is going to be useful in... yeah.
Yes.
Thank you. Please go ahead. Thank you.
Yeah. Thank you, sir. Thank you for the nice introduction. And I would like also thank DGH for giving me this opportunity. And Namang has introduced about machine learning and how it is done and what are the differences between supervised and unsupervised. Now I am talking about supervised learning. So here we have done this work in Buckroll field. There we have, in terms of production increase, we have done a tremendous job, and that workflow I am going to share here with you all. So this is my work, the session flow today. So basically, I will dedicate 3 slides on introduction about the field, about machine learning, and the data we have used. And last 5 slides, I will dedicate to results in terms of the quality and visualization of the results, as well as the impact it has created on the field development, as well as what are the implications it can have in the Indian scenario. So let me take the Buckroll field. So this is the part of Cambay Basin. As you know, Cambay has its challenges in terms of thin reservoir sands and sandwiched between coal layers, small layers, 2-3 meters layers. These poses a strong this thing on the seismic interpretability, seismic resolution part. So that is the challenge we have. And on the production side, most of the development has concentrated on the western part. And people were hesitant to go beyond because they didn't have some confidence there. So we were tasked with building up that confidence. If we can give something to go outside, then that will be very helpful. So we were tasked with that, and we have started the workflow, normal seismic inversion workflow. So we started with it. We wanted to do something. So after some stage, we found that it is not giving the results as we expected. So that time we thought, why not do the machine learning? So instead of anyway in seismic inversion also we are using the neural networks, but instead of that we take the seismic and directly predict the impedance or whatever seismic inversion parameters. And because nowadays we are having very good, very productive machine learning models. Those are designed very effectively. So we can use this advanced technology and we can predict the seismic inversion. And this initial stage we have got success. Then we thought, okay, it is working well. So why not we take the seismic and predict the raw logs instead of predicting the impedance? Why not predict all the raw logs? With that, if we give a petrophysicist, he can generate petrophysical parameters like porosity and water saturation, etc. And we will have a productive, an efficient tool in hand before going for the drilling. This is what our thought process. But how many of us believe that seismic can give seismic by predicting with the seismic attributes we can produce gamma ray or resistivity? This is not heard of. But the thing is, how many today it is happening with a simple text input. ChatGPT is generating image and Sora is generating videos. What is the relation between text input and video output? So the models have become very, very powerful such that they can extract the inherent relation between input parameters and output parameters. And we need to get the opportunity to take the advantage of these models. That's we thought. That's what our thought process, and we have produced the results. And though we have kept a few blind wells, and the results are pretty well matching with the blind wells. And those results I will show right away. So this is the data we have used. We have around 22 wells. These are all the logs. And we have taken, as Namang said, around 15 attributes, but we didn't do this principal component analysis. We thought the model takes care of the gradation of those attributes in terms of giving weightages. So we have taken around 15 attributes and we have predicted around 5 logs: gamma ray, resistivity, density, neutron porosity, etc. And we have used two networks, conventional neural networks. It has become famous in 2017 up to till the transformer model has come, which is used in GPT. And also later stage, we also found a way to use the transformer model, which is basic model for the ChatGPT and whatever nowadays LLMs. So with this, we have improved further the quality of the log. So performance wise, we have achieved with the CNN model itself around 80%, and we have improved upon it with the transformer model. So I am keeping here two wells. The left one is one well. Left logs are actual log, right ones are predicted log. You can see how well they are matching. Pretty well they are matching. Coals, that red part is coals. Coals also it is predicting well within that small thickness also. On the right side I have also included porosity and water saturation. See how the left one is the predicted and the right one is the actual. See how it is predicting very well the hydrocarbon presence also. Except at the place where the coals, two coals are there, it unable to resolve those coals and reservoir in between those coals. So that is where this CNN model is failing, but we have overcome this problem with the transformer model. So this is again CNN model output on the seismic section. Here I am showing the density attribute, And as you see here at the coal places, it has making that 2 coals as 1. That's why we are seeing a block section most of the places. Same section, the transformer model, and it is it is resolving those coals properly, and we can see at the deeper coal 2 coals now appearing properly. And also in the inset I have shown the green curve is the predicted and the black curve is the actual. And you can see the resolution from seismic to well log resolution we have achieved. So frequency has increased multifold. And this is the map view of those attributes. And now we can see on the unexplored area, undeveloped area, we can put some of the wells, and those we have kept. And all 6 are successful and they are producing now. So with this, I could conclude that here are 2 things. One is confidence building that we have achieved, and we have done all the 6 wells are successful, and with that we have increased production multifold, 3 folds we have increased. So here not only that, we have expanded our reach to undeveloped areas properly, and also we have repeated this process in another adjoint fields, and we also think that we can repeat this kind of success in fields across the India. So by this I conclude that this project demonstrates a strategic shift in exploration philosophy from cautious incremental exploration to data driven, more confidence data driven approach should be there. So here I thank my company who gave this opportunity, Ceylon Exploration, and thank you, sir. Thank you very much.
Any?
You said that there were 6 wells which were drilled based on your study.
Yes, sir.
So how is that match? How was that match?
So here it may be exaggeration if I say, but even prognosis wise, the sand thicknesses and prognosis depth also spot on. So even we didn't even get 1 meter this thing difference. So like that, but exact match may not be there, but we can see where is the reservoir sand, where it is not, as I have shown in the other well. Between 2 coals there is not match, but except that we have got a very good match, and with the transformer model we have also achieved that. So and I also forgot to say, by having these volumes, even in the 3D we can see, and where we are getting good property, and we can tweak the well location properly, and also the well path to get the better reservoir sands. So how this is how we have used this these volumes, and we have increased the production.
Okay, so I understand why you could not match your cool signatures. Could be because your data actually cool signature is a little bit of outlier.
Yeah, outlier and also resolution. And here we are predicting around 2 meter, 3 meter coals, and in between 2 meter, 3 meter sands with 30 hertz frequency size.
So again, this is an outlier in terms of your sampling of the data, which is what you are not able to capture it in the model.
Yes, sir.
So, but I think what you are making is a very sweeping kind of a statement that in future there will not be any need for a recording of actual logs. Your seismic is going to do enough of it. So how do you think the quality of seismic is going to affect your predicted log behavior?
Sir, after this we also done in 2 fields. In Kyrgyzstan also we have done, and we have achieved good results with the transformer model. But as I said, we need to have proper wells, number of wells should be there. So here in this case we have used 22 wells, And if we reduce it to 6 wells, 7 wells, we may not see this kind of result. So we need to have proper samples in that reservoir zone to produce good quality output.
Okay, thank you.
Yeah, thank you.
Good work.
Urja.
Hello. Yeah. So you said that you have used the 22 wells to start the analysis. How do you use those wells in your training in the initial stage? How do you use this?
So here these 22 wells we have concentrated on the reservoir zone itself, around 200 meters.
No, I am talking about you have not talked about the scalability between these two data sets. And what is the resolutions of the seismic for the buckroll?
Yeah, seismic
what is that thickness?
Yeah, so thickness ranges from 3 meters to 8 meters sands.
And what is the resolutions of the seismic you have used?
Seismic, as I said, is around 30 heads.
So what will be the equivalent lambda by 4? What it comes? Much more than this, your thickness.
Yeah, yes, sir. Yeah.
Now you make us to believe just it's submissions because we are talking very basic. So you use the 22 wells data, which is a very high resolutions data, and resolutions data means per meter you have the 7 sample points. I do believe in for every log.
Yes, sir.
And vis-a-vis. And you have used the seismic where the resolution is more than that 4 meters.
Yes, sir.
Now tell us something because we don't know about the ML and AI.
Yes, sir.
So you tell us how they connect it. What is the extra things you have supervised in your model?
Yeah.
They suddenly predict something log which is not missing with this.
Yes, sir. We also surprised why we have got this kind of result. And
also you have mentioned that you have not done that correlations, that cross. You have left that model to do that.
Yes, yes, sir.
So there are some of the things which is not clear to us.
Yes,
definitely it is more things, and
Yes,
you are thinking that I am not asking any questions. I am getting
sir,
myself
yes,
clear.
Yeah, I got
And you are switching to another field where the sand thickness is 2 to 3 meters. Cut distance you have told.
Yes, sir.
So how do you believe that the attributes which you have generated and you have drilled 6 wells is just honoring your model? Otherwise also it could have drilled and could have done this.
Yes, sir.
How do you exclude those things?
Yes, sir. Yes, sir.
So
I got this doubt how it is predicting pretty well and how it is increasing the frequency. So for this, what I observed is we are using around 15 attributes like derivative of frequency, instantaneous frequency, phase, dip, etc. And when we are using, even though it is 1 millimeter sampling interval or 2 millimeter sampling interval in our case, all these 15 attributes are not same, not exactly same from point to point. There is minute variation between point to point. If I take seismic, we may not see that kind of thing. Point to point, only one amplitude trace we take as input. It may not give that kind of variability. But here we are having a sweep of attributes. There, with well-log resolution, you are seeing variation.
Yep.
Even with a small bit of variation, the model is highly sensitive to these small variations, and that is reflecting in the producing different kind of output with the small variation.
Arun, if I may, yeah, that's what he was trying to point out. What he is saying is the seismic scale is different, the log scale is different, and when you say that, this is precisely what he was trying to point out.
Yes, sir.
So the seismic scale, when you talk about the frequency and then what is the resolution of a particular thing,
yes, sir.
Then are you able to, make a 2 meter or 3 meter and okay, coal you said that, but for me the coal, at least you have some density contrast, okay. So there also there is some. So the point is, it's a wonderful thing. So I think we should keep working on it.
Yeah.
But only thing is one thing what I wanted, because most of the things Mr. Asit and Ujjwal have asked, and then you have answered everything. But my one thing is, like, when you do the supervised learning, right? What happens is there should be a threshold level beyond which the difference is going to be very minimal. So what was that in this particular model? Like, see, you had 22 wells, right? It's a normal course of work what we do. Like, you go on blinding the wells and then you start opening, see the model. It's an iterative process. So out of these 22 wells, like say maybe after the 15th well or the 16th well, the model is going to be not very. So what is that?
Yes, sir. Yeah. We have
so because,
that also, and varying the number of wells input. And we have seen how
anyway, I think we are running short of time. Otherwise, there is a lot of things which we can discuss.
Yeah, I quickly answer this. Because we have seen that with varying number of wells and also varying thickness. If we take top to bottom of the well, this won't work.
Right.
We only need to concentrate wherever we are interested.
Then the following question is, how is it different from the normal density volume we prepare? How is it different from the normal porosity volumes we make, from the sweetness volumes we make? You know, there is n number of attributes.
Yes.
So the interpreter sits and decides what sort of an attribute is going to be working in this particular model and what is the maximum match, right? Yes. So anyway, I think the discussion can go on and on. Thank you for a wonderful presentation, and then please continue to do this, so that we come with more refined models, and then it doesn't mean that we'll not run logs, please. SLB is going to hit you, right? Thank you. Wonderful. Thank you so much. Give him a big round of applause, please. Thanks.
Thank you.
How AI and ML models are able to predict things so beautifully without knowing the science of it, because knowing the science or knowing the physics. So this is an area of research. I am sure that this is a larger question. He has tried to.
You already made that point, so that's why I didn't. The point is, what is the requirement of a seismic volume? What is the quality of the data which we need to? There are several things. But continue to do this, please.
But in his case, he needs to probe it a little bit. Deeper.
Thank you. Wonderful. So we'll now call Dr. Bappa Mukherjee. He is currently working as scientist in Varta Institute of Himalayan Geology, Dehradun. He received his MSc Tech and PhD from IIT ISM. His area of expertise are AI, ML, fractals, geophysical signal processing, exploration geophysics, logging, and seismic data. Last time when I met Dr. Kalachan Sain, he was showing me a thing of, I think you have developed something on processing, and straight away going to the size fishes. Yeah? Okay, good. Wonderful. Please.
Okay.
Yeah.
So thank you for introducing me, and thank you DGH and Urja Bharat team for giving me the opportunity to present my research work in this platform. And I am privileged to be here today. So today's talk, I will give you a brief overview how to deal with the missing log issues, which is one of the very common industrial issue in ENP industries. So mainly I will discuss the missing log prediction in a singular stratigraphic unit, but what we have to do more when we have the same problem in multiple stratigraphic units through a case study. Okay. So generally when we have dealing with missing log issue for a particular stratigraphic formation, so in that case we generally use the machine learning kind of stuff like k-nearest neighbor, support vector machine, decision tree, random forest, extreme gradient boosting, Gaussian processing regression, ANN, and there are many machine learning kind of stuff like AdaBoost and all those things. But this is the tools don't have the memory part, so they are unable to preserve the sequential information. Okay, so these tools are very good to predict the time series data, I mean other than log data also, any kind of time series data, but in particularly in field of geology when we are talking about a particular stratigraphy wise data is changing, so in that case these are very good. But in case of multiple stratigraphic unit, this tool run with several kind of problems like gradient exploding, and this tool don't have the memory unit, so in long run they will forget that what they have learned in long past. So there is a short-term memory loss. So this is the case study. I have taken the data from Assam-Arakan Basin, which is a very complex geological setup. So in that case, let us say the problem, where we have, I think, total 8 stratigraphic units, Girujan, Tipam, Berail, Kopili, Parang, Narpu, Lakadong Theria, and Langpar formations. And now we are having the missing data at multiple formations. Let's say in OL6, some part of the Berail and some part in the Kopili formation, there is a missing log N5. Newton porosity log is missing. And similarly, in the case of 13, there is a missing log in Narpu and Lakadong Theria formation. In case of OL7, there is Kopili Parang, like that. Main motto is log is missing in multiple formations. And we have to answer the missing log simultaneously. So these are the geophysical logs. And first one is the caliper log, then gamma ray log, resistivity log, true resistivity log, Newton porosity log, bulk density log, and photoelectric factor logs. And last column is basically the formation tops. So these are the logs of the OL2, OL3, OL4, OL6, OL7, 8, 13, and 15, like that. So in that case, what I have used, these are the deep learning tools: long short-term memory network, LSTM, bidirectional long short-term memory network, by LSTM, and convolutional LSTM, CNN and LSTM. So I am not going to brief on those techniques because these are all internet kind of things and you can learn it theoretical part. So what we have done, we have first amalgamated what are the log data available with us. So we have amalgamated the log data of entire formation, excluding the logs where the data is missing. Okay. So when we amalgamated all the logs, we have seen the training sample having the data sets in a single channel, say gamma ray log or resistivity log having the data sets of 35991. Okay. And second one is the correlation matrix, which we have to do this practice when we do this kind of deep learning kind of things. And this practice is very much need when we have more number of logs. Okay, here we have only 4 number of input logs, but when we in case of we have 7 or 8 input logs, then we can we must do this analysis. So what is the importance of this correlation analysis? This is very simple. You can just do it in Excel, XY plot, just that's only. And this is the regression value 0.0726, like that. But the importance of this, when we have more number of data, and if we get the similar kind of regression value from both of more or two or more than 2 number of input features, then we can exclude one. But it is theoretical explanation, but practically we have seen that if 2 or more number of input having the similar kind of correlation with the output data sets, and if we exclude one, then we lagging with the accuracy also. So it's data dependent and problem dependent again. And the last B is basically the through histogram analysis we are giving you the explanation of data distribution. Now again, feature engineering. This is also one of the important step in deep learning. Here we have computed the contribution of the each input features, that is resistivity, gamma ray log, photoelectric factor, bulk density log, and how they are contributing on the Newton porosity, which is the output in that study area. And these are the learning curve of the LSTM, bi-LSTM, convolutional LSTMs. And most of this is the analytical steps. And we have seen in LSTM, after we have got the flattened curve after 200, in bi-LSTM around 143, I think. And in LSTM, convolutional LSTM, it is around 70, like that. So it is very good practice to check how I train the model. So itself we feed the training data into the trained model first. And this equation in the C, G or K is basically the relation between the true and predicted one. And last column is the histogram, is basically showing that the error is basically concentrated on the 0 point. So we are now satisfied with the training step of the data set. Now this is basically the example result. We have fit the input data sets, means resistivity, gamma ray, bulk density and photoelectric factor, where the data missing at the OL 6, and we feed when we feed this data to the trained models. So these are the accuracy, and we have plotted the uncertainty analysis also to check the accuracy, how accurate they are. And this is the error that is basically simply difference between the output we got and the actual output we have. And table basically quantified the accuracy through 4 different parameters like root mean square error, correlation coefficient, means square analysis, and variance account for. So you can see in this case that predicted and actual data having the more than 98% similarity. So this is the example for OL7 where the data is missing in different two formations. And this is the last one for OL13. So thank you. Now question.
Thank you. Any?
Yes, please.
Have you seen whether your model was overtrained or no? Because your correlation coefficients are very, very high.
Actually, in that case, I particularly get I also confused when I got the test result, because in training, I got 91% accuracy. In test, I got the 96% and above accuracy. Generally, in test, we have less accuracy. So it's simply someone can say that it's a overtrained. But no, it's not overtrained, because here, our training data sample in a single channel we have 35991, and in test case